What's up, everyone? Vin here, and tonight starts the first live stream for the AP Calculus AB BC exam, and I'm going to do 50 multiple choice questions covering units 1 through 5. So, yeah, thank you to everyone who's already here. I like that we had a line of people waiting, so once again, thank you all for supporting and being here. So, yeah, I'm going to just get rolling here, but you're welcome to say hello in the chat, ask questions. The I guess rules for the live stream though, just please be respectful to each other in the chat. That's all I ask. All right. But nice to see you all and thank you for being a part of this. So I'm gonna hit refresh here just to make sure everything is up and running okay. All right, so we are good. So I'm just gonna get moving here. We have a lot of questions to cover. So first up, also the questions themselves, I have it written on the side here, right above my head. You could scan the QR code for the 50 multiple choice questions, or I put a link in the description to a Google Drive PDF file that you could download and follow along as I do these questions. So here we are. We have the limit as x approaches a of f of x equals L. And we want to know if L is a real number, which of the following must be true? Well, if we know that a limit exists, that's all that we know. Then I have some function like this. And if the limit exists, I could have a situation like this where I have a hole in the graph and my limit is equal to L, but my function could be undefined here. Or maybe I have a removable discontinuity. But just because my limit exists does not mean that my function is differentiable at A. Like, once again, what I just drew, and let me just bring this down a notch. Like, this is overpowering here. That at x equals A, let's say I have f of A is undefined. Okay, so this is, let's say, undefined. And if my function is undefined here, then it's not continuous. And if it's not continuous, then the derivative is not going to exist there. And once again, I don't need to have my function defined to have a limit. And the function value doesn't have to equal L. So none of the above are necessarily true. Okay, this is like a really big idea with limits. And this is, once again, I'm just going to say it very carefully. You can have a limit at a value of x where your function does not exist. You could have what's called a removable discontinuity. So which of the following must be true? None of them have to be true here. Okay, so now we're moving on, and let's see. Oh, watching this and Heimler's A Push review. That's awesome. I thank you. Well, entirely dependent on me. I hope you all do well here. Just put your practice in, and yeah, that's really all you could do, and then hope for the best. But I'll do my best to make this as helpful as possible. So, limit as x approaches 0 of 1 minus cosine squared 2x over 2x squared. For this one, honestly, I'm just going to use L'Hopital's rule. Okay, so I'm just going to use L'Hopital here. And for this one, we just have to be very comfortable with derivatives. In this case, specifically the chain rule. So if I derive this piece here on top, what I'm thinking is I have three functions here. Like when I look at cosine squared of 2x, I think of this as cosine of 2x, but then all of this squared. Because when we have to derive, now I'm going to say the limit as x approaches 0. And for L'Hopital's rule, what I'm doing is I'm deriving the top. So I'm deriving this. And I'm deriving the bottom. Okay, the reason why I'm using L'Hopital is if I go to plug in 0, like let's say I just say, oh, let me let x equal 0. I'm going to get 0 over 0, which is an indeterminate form. So I use L'Hopital. So when you get an indeterminate form and you use L'Hopital, you're deriving the numerator and denominator and then finding that resulting limit. So here, the derivative of 1 just goes to 0. And then I have minus, and when I'm deriving here, I'm doing the derivative of the outside. I keep the inside the same, and then I multiply by the derivative of the inside. So the derivative of the outside, I'm using the power rule. So I'm doing 2 times cosine of 2x. So notice I'm keeping the inside the same, and now it's to the first power. But now I do the derivative of the inside, and the derivative of cosine 2x is, I'm going to leave a space, negative sine 2x. Okay, but then I'm doing the derivative of 2x's too. And this is all over. The derivative of the bottom is chain rule. I have 2 times 2x to the first, but then times the derivative of 2x's too. And here, I'm going to have a whole bunch of stuff cancel out. So let's just see. We're going to have the... Yeah, well, you know what? Let me just get to simplifying this now. So from here, what we have is the limit as x approaches 0. And we have a negative times a negative is positive. I could chop off some of these 2's here. Like I could cross off this 2. I could cross off this 2 like this. And I have a negative times a negative is positive. So I have sine of 2x, cosine 2x, and then over 2x. All right, so we get here and we're like, oh no, 0 over 0 yet again. So from here, this is where I want to use the following like special trig identity for limits. The limit as theta goes to 0 of sine theta over theta equals 1. Just make that neater. Okay, equals 1. So basically, if the argument of sine and the denominator go to 0 at the same rate, then the limit goes to 1. So what I'm seeing here is this piece is resembling this. See, 2x and 2x both go to 0 at the same rate. So the part that I just boxed off in pink, that limit goes to 1. And then cosine of 2x, I plug in 0 and I get cosine of 0. Cosine of 0 is 1. This whole limit is equal to 1. Okay, so 2 should be choice D. All right. Oh, thank you at Nonoa45 telling everyone in your class to watch. I appreciate that. Yeah, definitely. I appreciate anyone helping me spread the word. My goal is to just make this as like nice as possible for people. I handpicked the questions to cover 1 through 5. Like it might, miss little details here and there, but it's like fairly comprehensive. So yeah, thank you for that. Do they use the other 6? I would say infinity over infinity is fair game too. So yeah, like if we had the limit as x goes to infinity of like, I don't know, let's say like e to the x over something like e to the, I'm just trying to, yeah, I would say maybe if I just make one up on the spot. So something like this. But this one here, you could just use your understanding that if the denominator is going to infinity faster than the numerator, then the limit goes to 0. But theoretically, you could L'Hopital this. It's an infinity over infinity L'Hopital. So yeah, that's the idea. Oh no, I'm cooked. No, don't be cooked. You want to be the one doing the cooking. So yeah, get to cooking. All right. I'm finally caught up on the lingo a little bit. Glad that it's trending everywhere. So here the limit as x approaches 1. But yeah, the most popular one is 0 over 0, but also like infinity over infinity. But we have like ways of dealing with that. 1 from the right. So notice here x equals 1 is over here. So I'm following the graph from the right side. And we're going up to y equals 2. Okay, so 3. Question 3 should be choice C. If they asked us, just so we get everything, oh yeah, let me just write it out here, was equal to 2. If we wanted to find, let's say, the limit as x approaches 1 on the left side, then here we're approaching negative 2. So in general, like I see choice D, like why this is no good. Like this is no good because it's the left limit. This is no good because that would be if they were asking what is the limit as x approaches 1. And this limit here does not exist. Right? If I had to write it because, because my left and right limits are not equal. Okay, the limit as x approaches 1 on the left does not equal the limit as x approaches 1 on the right. Okay, so it's good to explore the other answer choices. So plus is approaching from the right, negative is approaching from the left. Yeah, plus, if you're approaching from the right, what I think of is like, oh, plus right, you're moving. I just think you're going from right to left. So say right first, but you're going from right to left. If you're approaching from the left, you're going from left to right. Okay, so that's how I handle those. All right, question 4. Yeah, it's going to be a bunch of limits, and then eventually we'll get to derivatives, and then harder questions. So here, something like this is a little annoying to deal with, but it's properties of logs. So remember your advanced algebra days, if you have ln of like a over b, this is natural log a minus natural log b. So this one, before I L'Hopital, I'm going to do the limit as h approaches 0 of, and for this one here, we're going to have natural log of 2 plus h. We have 2 plus h minus natural log 2 over h. Okay, so 1 over h multiplies to just make a denominator of h. And then here, if I plug in 0, I get ln2 minus ln2 is 0 over 0. But if I L'Hopital this, I'm going to get a 1 in the denominator, and the derivative of ln2 plus h is just 1 over 2 plus h. Don't say minus a half. This is constant. Okay, this is constant. So the derivative of that is 0. And then you plug in 0, and you get 1 over 2 plus 0 is 1 over 2. This is kind of like the trap. Some people see this, and they're like, they go, oh, is this 2 pi? But like, no, don't power rule this. The derivative of a number is 0. Okay, so don't do that. This is a constant, so it's equal to 0. So people want to say 1 over 2 for this, but don't. Just say 0. Alrighty? So there it is. Cool. Question 4 is choice C. All right. Next one is similar. This one I'll show a slightly different way. If you want to just L'Hopital everything in sight, though, just L'Hopital. But the limit, let me actually write this first. The definition of the derivative as the limit of the, difference quotient. So the limit as h goes to 0 of f of x plus h minus f of x, and then this is all over h. So here, when I see this, it's in the form like, oh, I recognize this. This is in the form of, the limit definition of the derivative. The piece that jumps out at me is this. Okay, so what this is telling me is that our function is cosine x. However, the whole expression here, limit as h goes to 0, is the derivative. But notice that here, x is equal to 3 pi over 2. So really what we're looking for is what is f prime of 3 pi over 2. So if you could handle this algebra, then you don't have to L'Hopital this. You could use the definition. But I don't know, I just tell students, like, just L'Hopital. L'Hopital is, like, pretty reliable. So here, f prime is negative sine x, so we would get negative sine 3 pi over 2. And sine of 3 pi over 2, just know the unit circle. 3 pi over 2 is down here, and the y value here is negative 1. So this is negative 1, which makes positive 1. Okay, so 5 should be choice A. But once again, you could just L'Hopital this too. If you want to see L'Hopital, then it would be denominator 1. But this you have to chain rule. But the chain rule here, the derivative of the inside is 1 because it's 3 pi over 2 plus this. So you really just get negative sign. And then you get 3 pi over 2 plus h. All right. Minus the, let me just section this off. Minus the derivative of a constant is 0. You see, like either way, you're getting negative sign. When you plug in 0, you're getting negative sign 3 pi over 2. All right. Cool. Oh, hello in the chat. Does anyone know whether, let me see. If they were asking for f of 1. Yeah, sometimes I lose track. Yeah, f of 1 would be negative 1. So yeah, thank you for crossing off that last answer choice. I like to go through all the wrong answers. I mean, shout out if the student who referenced this to me happens to watch this or stops by at some point. But one of my former students who was like one of the top test takers like I ever like had in my class just got like perfect scores on a lot of like really hard tests. And I remember asking him like, "Hey, what's your secret?" And he said one of the things he does with multiple choice is he doesn't just get the right answers, he's able to explain why all the wrong answers are wrong. So at Norwatch, if they were just asking for f of 1, that would just be negative 1. Yeah, like that. I like that we took care of that last answer choice. I might not have enough time to do that for every question here, but like when you're practicing and you have time to like go at a casual pace, that's a good way to think. All right, so let's see. The graph of a function f is shown above. If the limit of, the limit as x approaches b of f of x exists, and f is not continuous at b. So if these two things are true, so the limit exists, but f is not continuous. So the limit exists, but f is not continuous is a removable discontinuity. Okay, so this is a situation where the limit exists and the function is not continuous. So just be careful because the only other case where the limit exists is where like the function is continuous. So you could either have a removable discontinuity or a continuous function, and that would make your limit exist. So I read the question and then I just imagine what the part of the graph is going to look like that I want. Okay, so I just think, oh, the limit exists would tell us here the limit as x approaches b of f of x exists. Let's just say that it's equal to L in our heads. Like I'm looking for something that looks like this. So right away, my attention is drawn to this part of the graph. I'm like, oh, here's a location where the limit exists as I approach 0. See, my left and right limits are heading to 2, but my function value is at like 1.5. Okay, so I would say here, the limit as x approaches 0 of f of x exists, but f of 0 does not equal the limit as x approaches 0 of f of x. Okay, so the limit does exist, but this is not true. So it would have to be 6 would be b. All right, let's go through the other answer choices. Negative 1 is no good because the limit doesn't exist here. See, left side goes to minus infinity and right side goes to infinity. So this one's out. At 1, the function is continuous. See, we could draw this part of the graph here in one motion. Like this part in the neighborhood of 1, we could draw that in one motion. So this is out. 2 is no good because this is a jump discontinuity. So this is a case where the limit does not exist. See, the left side limit, if we do this in pink, the left side limit is heading to 2. And the right side limit is heading to 1. So the limit doesn't exist there. And at 3, the function is continuous in this neighborhood. So this is out. All right, so definitely choice B. Oh, at Vin the Goat, I appreciate the vote of confidence. I have a ways to go, though, before I get there. But I appreciate it, for sure. I'm just having fun, making these videos. And doing the live streams has been, honestly, I think the live streams are my favorite because I get to actually talk to everybody. When I make the videos, it's just me. And, I mean, I'm in the zone when I'm doing it. But it's nice to be able to actually connect with my audience. It's like being in a classroom, like in person, like when I get to talk to all of you. So does anybody know whether the integral or derivative of absolute value functions are tested on the BC exam? So at Alex, the most they would make you do is like maybe like just analyze here. If you have an absolute value function, you treat it piecewise. That's like honestly the most I could see them doing is like you're saying like, all right, f of x, if it's like absolute value x, you could write it like this. Like that was terrible. Try that again. Not my best. Here, that's a better curly bracket. If x is greater than or equal to 0, and then negative x if x is less than 0. So if they ask you to integrate absolute value x from like, I don't know, like -1 to 2, honestly, I would just find the area of these two triangles. Use geometry. I mean, just because you know calculus, you don't have to use the fundamental theorem of calculus. All right, but that's more unit 610 territory. So I would find the area, just find the area of those two triangles. But deriving it, I'm just saying, oh, the derivative, like the slope of this line is 1. I'll call that like slope 1. And slope 2 is -1. So usually like you just analyze it piece by piece. They're not going to make you use some wacky formula like or anything. All right, so here, limit L'Hopital again. Yeah, L'Hopital is like a pretty powerful technique, especially for Calc BC, because I don't know, me personally, anyone who's in BC that's not in my class, I feel like there's just not enough time to really get heavy into Unit 1, so we just L'Hopital everything in sight, like I'm about to do right now. Go to the 7th, and then -0 over 1, and then I plug in 0. So I get 64 times 1/2 to the 7. And this one, just powers of 2. I know 2 to the 5th is 32, so then 64, 128. So I'm doing 64 times 1 over 28. And that simplifies to a half. Okay, so yeah, calculator skills. Oh, I appreciate that at Norja. I appreciate these videos. They're useful. I just, honestly, I really take the time to make sure. Yeah, tomorrow's going to be 6 to 10. So this is day 1 of 4. Tomorrow's going to be day 2, units 6 through 10, 50 multiple choice questions tomorrow as well. But, 6 through 10 ones. So it'll cover like A, B, and BC. So A, B people might tune out for the last part. All right, so here, this is the limit at infinity. So as x goes to infinity, when you have a limit as x goes to infinity, I like to just focus on the leading terms. Like this is honestly the only math I'm doing in my head. Is I just look at the leading terms. And in this case, I'm like, oh, they match. So I'm like x squared over -4x squared. So then I go like this, and I'm like -1/4. Choice B. And that's it. You could L'Hopital twice if you want. My last day is going to be Sunday. But I'm going to switch Sunday from 1 p.m. to nighttime because I didn't realize when I made the schedule that it was Mother's Day. And I would want all of you to spend, time with your family. I know I'm going to celebrate with mine. And then when my kids go to sleep, yeah, I'm going to try to get them to bed earlier on Sunday so I could start the live stream earlier because the test is Monday morning. But that's why I scheduled these at 8 because I have 2 young kids, and I need them to be asleep while I live stream because they'll want to like play and take the pen and stuff. All right, question 9. Here's f of x, f of 2 equals k, and we have if f is continuous at x equals 2, then k equals. So if f is continuous at x equals 2, you have to know this definition. I'm going to write it out. This is like for the free response questions. If you ever have to explain something is continuous at 2, you need to show that the limit as x approaches 2 of the function is equal to f of 2. Okay, so here, what I'm going to do is find the limit as x approaches 2 of f of x, which is the x not equal to piece. It's this messy piece. So this one we could also L'Hopital. But if you want to practice the algebra, I guess we could practice the algebra. That's up to you, though. I don't know. I'm just going to L'Hopital. I don't know why. If you want to do algebra, then do this. You multiply by this, top and bottom. But is that going to be, what's that, 2x plus 5 minus x minus 7. So that's like x minus 2, which will cancel this out. Yeah, so you know what, L'Hopital, but chain rule this. Or I already wrote this, so maybe I'll just do it this way. Yeah, it was a... All right, so this one, if your algebra game is strong, when you multiply a plus b times a minus b, a binomial and its conjugate, it's a squared minus b squared. So I think of this as like my a and my b. So I'm going, you know, let me write it higher. Oh no, that's all. All right, you know what? Let us say this. This is going up here. So this would be the limit as x approaches 2 of 2x plus 5. I mean, radical 2x plus 5 times itself is 2x plus 5. So this is like our a squared minus our b squared. Radical x plus 7 times itself is this. And then over, I have x minus 2 times that mess. The radical 2x plus 5 plus radical x plus 7. So you could L'Hopital this, but if you just want to see the algebra, here's the algebra. So now this minus x minus 7 is going to make the limit as x approaches 2 of, I'm going to get 2x minus x is x, and 5 minus 7 is minus 2. So you see these factors over here are going to cancel. And let's just say I have a 1 left up there. So I get radical 2x plus 5 plus radical x plus 7. And now I just plug in 2. So this is 1 over, this one canceled. Now the square root of 2 times 2 is 4, plus 5 is 9, plus the square root of 9, which is 1 over 3 plus 3, 1 over 6. Please be B. Yes. All right, choice B. All right, or just L'Hopital it. Whatever makes you happier. Oh, Fortnite. Nice to see you. Hope Algebra 2... No, geometry and Algebra 2, right? You're studying for Algebra 2? You signed up for both, right? I think the last time I checked in with you. So, hello. And yeah, thanks for coming on to the live stream. Which of the following functions are continuous for all real numbers x? So this one, we have continuous, the 3rd grade definition. You could use the fancy limit definition. Oh, ask your question about geometry. Go ahead. Is you could draw it in one motion. So stuff like e to the x. I'm like, oh, I know what this looks like. It looks like this. So this one, yes. So you're out. This one's out. And wait, does that? Oh, I thought it eliminated everything. So tangent x, it's basically going to be eliminated. But tangent x, if we had to draw it, is going to look like this. Okay, so it has infinite discontinuities. It has a bunch of vertical asymptotes. And then x to the 2/3, I call this one the bird function. It looks like this. All right, and the reason why it's not an issue, some people might say, wait a minute, what about negatives? Is that if y equals x to the 2/3, this is cube root of x squared. Our power is odd, so it doesn't matter what we take the cube root of. But x squared is always greater than or equal to 0, so this has no restrictions here. So this one is good, and I could draw the bird in one motion. So 10 is choice D. Okay, and let me just see. If you construct a perpendicular bisector or regular perpendicular line, you know how it forms? Yeah, but let's say my angle... Yeah, so at Fortnite, I would say 99.99999% of graders are not like going to be crazy. They're not going to bring like a magnifying glass and a protractor. Like, all right, you like they're, as long as your construction marks are there. So you need to have the construction marks. Like that's the most important part of your construction to get the full credit. They understand that like the school issued compasses are like not like made from steel. You know, it's not like German engineering or something that's gonna like really, like I don't know, like BMW or Mercedes quality. So they allow like a small margin of error, and being 1 degree off is like, yeah, definitely okay. But I appreciate your enthusiasm and like attention to detail. If you're designing a bridge, you wouldn't want to be off by a degree, but on a Regents, they'll be fine. Oh, how did I know that the from teaching this class for many years? But otherwise, it's I would say at Maria, more like think about domain. As long as the domain is all real numbers for like a rational function, I'm sorry, with a rational exponent, it's going to be fine. One that would not be continuous for all real numbers x would be like, let's say I had g of x is square root x, because the root, even though it's invisible, is an even root. But odd root, like this, we could plug in any x we want, so it's going to be continuous. But it doesn't matter what it looks like. If the domain is all real numbers and it's a, rational exponent, it's going to be continuous everywhere. I wouldn't worry about memorizing that. Remember, the more important things to know is this. Like this, I would memorize. Make sure you know limit definition of continuity. But remember, BC people, unit 1 is like 4 to 7% of the test. So it's not going to really hurt your score if you forget obscure bird function graphs. All right, so let's see. The function f is defined above. At what values of x, if any, is f not differentiable? Ooh. Oh, this is going to be tiring. Okay. So 2 over x, let's just see. If I plug in -1, where my head goes right away is let's see how these match at -1. Like I would plug -1 into this and this. I would go, all right, 2 over -1 is -2. And if I plug in -1 here, -1 squared minus 3 is -2. So this thing over here is continuous at x equals -1. So if I think about this, like 2 over x, the whole graph would look like this. But if I restrict it to, x is less than -1, then I have like this open here like this. But then x squared minus 3 is going to connect at -2, and it's going to go like this. Okay, until 2, and at 2, it's going to bring us to 1. I'm just doing this math, yeah, like in my head. And I know it's going to go to 1 because if I highlight this piece over here at 2, so if I, like expand this piece, if I plug in 2, I get 2 squared minus 3 is 1. And, oh, wait a minute. Actually, no. At x equals 2, we have, I was doing some math in my head. 4 minus 3 is 1, but then this piece, 4 times 2 minus 3, if we plug in x equals 2 here, we're going to get 5. So that means this line is going to start up here at 5 and then just go up. I know it's going up because the slope is 4. So you see here we have a jump discontinuity. And if our function is not continuous at 2, so f is not continuous at x equals 2, this implies f is not differentiable at 2. Okay, if you're not continuous, automatically you're not differentiable there. Okay, x equals 2. So 2 is out. The only one that's not going to be differentiable everywhere. So it's not going to be differentiable at 2 only. We're looking once again where it's not. So, oh wait, I'm sorry. They're asking, let me just be careful. At what values of x is f not differentiable? So f is not differentiable at 2. So -1 only is out. This is out. Oh, that just eliminates all of them. Look at that. Because, yeah, if f is not differentiable at -1 and -2, they forgot x equals 2. F is differentiable for all values of x. No, it's not differentiable at 2. Sorry, I'm a little tired. So, like, that part is, like, annoying when we find something. But this would imply, this answer, that it is differentiable at -1. So how could I verify that we're differentiable at -1? Like, if I just want to say a little extra, I would derive f prime. The derivative of this is the same thing as 2x to the -1 is -2x to the -2. And -2x to the -2 is the same thing as -2 over x squared. The derivative of x squared minus 3 is 2x minus 0, and then the derivative here is 4. And this is for x less than -1, but they're saying here that it's differentiable, at -1. We're not differentiable at 2, so 2 is now removed. Small detail here, but notice that 2 is removed from the domain of f prime because f is not differentiable at 2, so that means f prime of 2 can't exist. But now watch what happens when we plug in -1 to the top and bottom. I'm sorry, the top and the middle, like this and this. If we plug in -1, you see how, like, left side and right side, I have -2 over -1 squared. And for the right side, I have 2 times -1. These are equal. -2 equals -2. So not only is my function continuous at -1, it's differentiable at -1 because the left and right side limits of f prime are equal. But remember, when you check f prime left and right, you have to make sure that you check continuity because I call it the bear trap. All right, I should have a bear roaring, but this is dangerous. What some people might do and get this wrong. So let me get this out of the way. So the trap, ready? So I'll say bear trap because that's my part of my brand. So the bear trap. All right, so the bear trap here is people are going to derive, and then they're going to go, oh, 2 times 2. You see, they're going to plug in 2 to this piece, and they're going to say, oh, here, 2 times 2, it does equal 4. They're going to be like, left side equals right side, continuous at x equals, differentiable at x equals 2, but no, it's not differentiable at 2. You have to check continuity, and remember, there was a jump discontinuity here. So jump discontinuity means not differentiable. So 11 is choice B. Good question. All right. Oh, here we go. An easy one. I mean, easy-ish compared to the last one. That was like just tiring. So here, the derivative of x is 1 plus the derivative of sine x is cosine x. Yeah, that was like a polite question. This might be like question 1 of the test, All right, let's see. So here, quotient rule. This is 13. I'm going to say this is the bear trap. So here, someone might go, oh, f prime is derivative of x minus 1 is 1 over 1. But, like, no. You have to use quotient rule. Okay, so quotient rule. Oh, these questions, honestly, I grabbed from, like, previous, like, old exams that they released to the public from, like, the 1960s all the way up to, like, the 1990s. And then the questions from the class description, like the course description, I just grabbed some interesting ones. So I had like a bank of questions that I could just grab randomly, but I just try to balance it with all the units. Like as we move forward, you're going to see it's going to go into like applications of derivatives and whatnot. So here I'm using the quotient rule, and I'm using this version here: u over v prime equals vu prime minus uv prime over v squared. So here u prime is 1, v prime is 1. So I have vu prime, that's going to give us f prime of x is 1 times x plus 1. minus 1 times x minus 1 over the denominator squared. So over x plus 1 squared. So this, if we want to simplify, is x plus 1 minus x plus 1. See, I'm distributing here. Distributing the minus. And now x minus x cancels. And we're over x plus 1 squared. So simplified, f prime is 2 over x plus 1 squared. Okay, so f prime of 1 is 2 over 1 plus 1 squared. All right, 1 plus 1, first day of school, it's 2, and we're squaring it. We get 2 over 4, which simplifies to a half. Okay, so 13 should be choice D. Does the domain have anything to do with the question? Not this one, if you're talking about this one at Appraise It, because they're mentioning here x does not equal -1. So we're not going to run into any issues here. If we were to graph this, we're going to have a vertical asymptote at x equals -1. But we're asking about the derivative in this neighborhood over here. So it's not going to be a problem because we're not trying to differentiate at the vertical asymptote. We're on a differentiable part of the graph. Okay, so but good question. The domain will come into play at times. It's definitely something we want to think about. But that question was just kind of pure technique. All right, here is product rule. So product rule says uv prime equals u prime v plus uv prime. Okay, that prime is attached to the u. So here I would just define u is equal to x squared and v is equal to e to the x. And now u prime is 2x and v prime is e to the x. So here, dy dx, I'm just going to write it over here. U prime v, I'm doing 2x e to the x plus, and then I'm doing x squared e to the x. And now this one, you're like, oh no, my answer's not there. And that's because they factor. So the greatest common factor is x e to the x. And if I divide this by x e to the x, I'm left with 2. If I divide this by x e to the x, I'm left with x. So commutative property, I just flip those, and it's going to be 14 is choice C. And I just want to double check that I'm, yep, choice C. Moving on. Oh, I like 15. So 15, algebra will save you. So the cool way to do this, style points, you ready? Natural log of e to the 2x. If you want to derive these, natural log and e are opposites. So see you later. Algebra first, then calculus. So we're left with the derivative of 2x is 2. Okay, 15 is e. Alrighty, that's the way to go here. Oh, hello, and oh wow, we have 40. We have a full class here right now. How awesome! I do appreciate you all for being here. It's so cool knowing, this time of year is extra special. Knowing that there's that many people on board. So thank you for being here. Is there any chance that you could host the final day review stream earlier? At Gia, I'll do my best to try maybe around 7ish. I'd have to find a way. I have to do some planning. But yeah, as of now, I could really just do the night, the nighttime. Yeah, because I am a family man. I do have kids, so I'll do my best though. I'll see what I could work out if I could find a babysitter or something. All right, and class are. Oh, David, give it time. The questions will heat up a bit. Okay, give it time. There's an optimization one at the end. So, and unit 10 is tomorrow, so it'll get worse. So here, if the function f is continuous for all real numbers, and if f of x equals this when x is not -2, then f of -2 equals. So really here, they're asking us to consider this. If it's continuous for all real numbers, then that means it's continuous at -2. So the limit as x approaches -2 of f of x has to equal f of negative 2. So here we've got the limit as x approaches 2. I'm sorry, negative 2. Fix that. Of f of x, and I'm going to factor this. Okay, we could we L'Hopital? Yeah, we could L'Hopital if we want, but I'll just do algebra. And this is negative 2, I plug in, minus 2. See, I'm just plugging in here. Okay, actually we'll go. And this is negative 4. So the limit is equal to negative 4, so we would want f of negative 2 to be equal to the limit. So 16 is A. All right. Yeah, that's why I'm only going to do one optimization question. I agree. If you want to optimize your studying, you should really just spend time on the biggest topics that are the biggest percent of the test. And optimization, I mean, if you want that perfect score, go for it. Do L'Hopital. Oh, at Aiden, if you rewind back to like questions 1 through like 10, I think I did like 7 L'Hopitals. Okay, so yeah, so I would, if you want to like go back for a minute and like just watch like one of those beginning questions, like just looking at my papers, like question 2, question 4, I L'Hopitaled. Question 7. Yeah, so those are all L'Hopital for sure. So I would, yeah, replay that. So at x equals 3, the function given by f of x it's definitely defined because you see how it has the equal to here. So it is defined. Continuous but not differentiable, differentiable. All right, this is impossible. You can't be differentiable but not continuous. Once you're differentiable, you are continuous. So here, we got to just go through this piece by piece. So I'm going to analyze the left side. And this is all, let me draw that nicer. That was not my best hat sign. So this is all at x equals 3. I'm analyzing left and right. So when I think about the number line, so 3, when we're less than 3, let me actually use a different color. Less than 3, we're on the left side. When we are greater than or equal to 3, we're on this side. Okay, so that's how I kind of reason my way through that part. So if I plug in, I have 3 squared, and ask ourselves, is this equal to 6 times 3 minus 9? And yes, 9 is equal to 18 minus 9. Check. So it's continuous. It is continuous. So neither is out. So it's either both or just continuous. So now we go an extra step. We have to derive. So f prime is 2x when x is less than 3. And it's just 6 when x is right now, temporarily, I leave it as greater than. Okay, so this is like questionable. Like, is it greater than or equal to? But I use this left-right trick again, and I go 2 times 3 and ask ourselves, is this equal to? If I plug in 3 to the right, there is no x, so it's just set it equal to 6. And this is true. 6 is equal to 6. So check. So now I can get rid of that question mark and say it is differentiable at 3 because the left and right side limits of f prime at 3 are equal. But remember, I have to check this first. So it's both continuous and differentiable. 17 is E. I have related rates on here too. For the FRQ, I would say your most important questions are rate in, rate out. And also, everybody, Saturday, I'm going to do FRQ. I'm doing 10 questions. All right, but you want to know rate in, rate out, big time. Rate in, rate out is big. I would say for Calc A, also, is this for Calc AB at Eric? Because, Eric, if it's Calc AB, I would say for sure rate in, rate out, and that's for BC and AB. Because Unit 6 is like massive. Although rate in, rate out is technically, I guess, like a subset of Unit 8 as well, because it's like the applied, accumulation using definite integrals and applied context. But yeah, rate in, rate out, you want to know? The motion questions for Calc AB, like the velocity, acceleration, all that. Differential equation is big. Graph of F prime is really, really big. Those are like some really, massive ones to know. Oh, BC. All right, so if you're aiming for BC, I would know rate in, rate out, parametric or polar, and obviously unit 10, sequences and series. Like, be really good at those three. The differential equation for BC, if it is unique to BC, is going to include Euler's method or like maybe logistic differential. All right. You want your improper integral game to be strong, but don't make the mistake of like, oh, BC is so hard, let me not worry about the AB topics. Like, AB could creep up on you and be a challenge. Like, there are some really hard AB, FRQs that, remember, 3 of them are going to be identical. Saturday is going to be same time as this. So yeah, 8 o'clock. Unless my kids fall asleep earlier, then I'll just get on early to say hello and take like free. I'll just take questions randomly. So yeah. All right. So here we have h of x, and we want to find h prime of 1. This part here we need product rule. Product rule. So we start this off. H prime of x. I'll just write it over here. Is product rule. So we have f prime g plus f g prime, and then plus 2g prime. I'm going to move this over. I ran out of real estate. Okay. So product rule, and the derivative of 2g of x is just 2g prime. So h prime of 1 is f prime 1. Okay, let me make that neater. It's going to bother me. F prime 1. I have to eventually get a new like tablet and pen because it's like I can't just write freely as fast as I would like. It glitches a lot. I think it's more the program though. Not 100% sure. Okay, so we have this. And now we just go on a scavenger hunt. F prime of 1 is -4. So I have a -4 here. And that's the only f prime of 1. Cool. G of 1 is, let's see. So G of 1 is -5. And then we have f of 1 is 2. All right, and we'll just say plus. And then, oh, here we go. G, so 2 times G prime of 1 gets used twice. So let's see. Did I not use? Oh, I think I didn't use. G prime of 1 is 3. And now just simplify carefully. So this is positive 20 plus 6 plus 6. So 18 should be A, 32. Okay. Yeah, I'm going to post this at Ruben. I'm going to have this saved. So yeah. At Harry, how do I find if a function is differentiable? I don't know if you just got here, but question 17, I would check out if you want to rewind a second before coming back. And also, I want to say, yeah, question 11, I did a little bit of a deep dive into differentiable as well. Okay, so 11 and 17, check those out. Oh, chain rule P or Q. You're talking about the fundamental theorem of calculus with chain rule. So yeah, at Maria, I'm gonna go over that on tomorrow's live stream. That's for unit 6, but I'll call it a movie trailer for tomorrow. So if this is the formula you're thinking of, the derivative of Q of X, P of X, and this is like F of T dt. So when you have something like this, it's F of P of X, P prime minus F of Q of X Q prime. All right. So that would be it. Yeah, that one. But that's tomorrow. I'll do stuff like this. Yeah, unit. That's like, yeah, unit 6 territory. Let me just group this and shrink it. Okay, yeah, I'll just leave this over here. All right. Oh, here we go. Conceptual. So this one here, we really have to think or draw. So think. These questions, my advice is think or draw. So all we have is that we have f and g. They're two things, continuous. They have continuous first and second derivatives. So that just means like when we draw them, they're connected and smooth. And this is a big detail. F is less than or equal to g for all real x. Which of the following must be true? So is the derivative of f always less than or equal to the derivative of g? Not necessarily. And what I'm imagining, at least, is a graph where, let's say, f I'll put in red, and then g I'll put in blue. So g just has to be above f the whole time, or they have to match its own parts. So let's say I have a situation like this. So almost like a sine curve. And for f of x, I'm going to draw something similar. But let's say it's let me draw it again. Maybe something like this. I don't know. Let me see if that contradicts things. So now let's see here. F prime is always less than or equal to g. Notice here at, let's say, like this value c. See how the slope here is positive? The slope here is negative. So if this is g and this is f, you see Roman numeral 1 we could chop. This is not always true. Okay, that's not always true because, once again, see how at the same value c, g prime is negative, f prime is positive. So if your g prime is negative, it's going to be less than a positive f prime. So that's out. Now, how about this? F double is always less than G double or less than or equal to G double. That one I don't like either because let's see where. How could I do this? A part where this one is smiling. Oh, here we go. Like here. Let's say I go like C2. I'll call this like C1. And let's say here C2. That in this case, like at these points, see how here the graph is concave down. So like f double prime of C2 is less than 0. And how do I know it's concave down? Concave down is when the graph frowns. Concave down is sad, right? It's frowning at you. Concave up, the graph is happy, smiling. So you see here, oh, wait a minute. I should have said G double. Sorry, G double. G double of C2 is positive, and this is F in red. F double of C2 is positive. Okay, so G double is negative. I'm sorry, G double of C2 is negative. F double of C2 is positive. So you see that contradicts this. A positive would not be less than or equal to a negative. So it's either none or 3 only. And this one here is looking like 3 is good. Because, oh, I'm sorry. This is unit 6. My bad. Sorry, unit 6. But whatever. I'll talk about it anyway. The area under F is definitely going to be less than or equal to the area under G from 0 to 1. Because if this is always like G is above and this is below, the graph that's higher is going to have a greater area to the x-axis. Now, some people might say, wait a minute, what if they're both under the x-axis? What if we had a situation like this, where it's like this and like this? Well, the one that's above the other is going to have an area that's like less negative than the other. So that's why 3 is good. Yeah, I like questions like 19. They're very like, thought experiment, like heavy. All right, this one is just technique again. Eventually, pretty soon, we're going to be straying away from, it's like by question Yeah, 28-ish is like heavy chain rule, but we're going to be branching away from this pretty soon. So this derivative of x to the minus 3 minus x to the negative 1 plus x to the second. So first thing I'm doing is deriving. This is negative 3 x to the negative 4. And now this will make negative 1 comes down to make this plus x to the negative 2. And then this is plus 2x. So then here at negative 1, and it's multiple choice, I don't have to write this all fancy. I'm going to have negative 3, and I'm going to put this like over x to the 4th. And I'm plugging in negative 1. Plus x to the negative 2 is 1 over x squared. And I'm plugging in negative 1. And then plus 2 times negative 1. So now this is positive 1. Negative 3 over positive 1 is negative 3. This will make positive 1 over 1 is going to give us a plus 1. And this is going to give us 2 times negative 1 is minus 2. So this makes minus 2 is minus 4. So 20 should be choice B. And it is. All right, so let's move on. 21. Oh, inverse derivative. All right. Are questions like this? Yeah. So at Norja, yes, they're gonna have easy questions that are like pretty straightforward, like this, and then they're gonna have ones you're gonna have to think. Like I would put this one as like a medium-ish, borderline difficult question. It's hard for me to say which ones are the worst, but like this one, you really got to know your stuff. You got to think, and you got to be able to create something. So that's like a hard question where you have to think or draw something out. This one is like just all technique. So if I say, let's see, the table above gives a differentiable and decreasing function f and its derivative. G is the inverse of f. So what is g prime of 2? Well, g prime of x is f inverse prime. This is how I like to write it. F inverse prime of x. And this is 1 over f prime f inverse of x. Okay? If you forget that formula, you could prove it using the definition of an inverse and chain rule. So yeah, but I'll just say know the formula. So here, g prime of 2 is 1 over f prime f inverse of 2. All right, let me just fix that, make that a little neater. At some point, I'm going to need a calculator, and I have the calculator software here. So what makes it a little annoying is you have to go on a scavenger hunt. And you have to know that inverses and functions and their inverses are opposites. So I want to know, like, when is f equal to 2? So I look for a y value of 2, and I'm like, oh, here. And I say f of 1 is equal to 2. So that would mean that f inverse of 2 is equal to 1. So I could write this now as 1 over f prime of 1. And now f prime of 1 is here, negative 5. So it's negative 1/5. Choice A. Yep, we're good. Are my test questions average, harder than AP tests? That would depend. I've had students come back and say, oh, the multiple choice wasn't bad. I've had years where the kids were like, the multiple choice was the worst. So it really depends. But these are like from old AP exams, like the ones they released to the public. So I would say they're just about on par with the AP test. All right. Now this one, oh, someone was asking before about derivatives and integrals of absolute value. So this one, I would know how to transform a function. So here's absolute value x. So this is sending it, like if I have f of x, is going to send this. So let's see, 2 plus. Is going to send this to the right 3 units. Let me just redraw this. So it's going to the right 3, and it's going up 1, 2. Okay, so transformation of functions. You have to know how to transform a function. So when they say, what is the value of the derivative of f prime? Oh, I'm sorry, then the value of the derivative f prime at x equals 3. So here, there's a sharp turn. Okay, so it's non-existent. If it was, let's say, anywhere else, like let's say it was at 4, f prime of 4 would be equal to 1. Because this is a slope. See how there's like a 1 in front of it? This has a slope of 1. This one has a slope of -1. So if they wanted something less than 3, like f prime of, let's say, -1. Actually, that's a bad number because I'll use like -3, let's say. That would give us -1. Like if I was like way out here at -3, I would be on this line. So I'd have a slope of -1. Okay, but non-existent because we're at the sharp turn. So cool. All right. Oh, a L'Hopital again. So this I would write like this. This is x over sine x. Okay, that's cosecant is 1 over sine x. And then here, I would L'Hopital. Because you got 0 over 0. And you're going to get 1 over cosine. And when you plug in 0, you have 1 over cosine 0. Which is going to give you 1 over 1 is 1. Okay? Cool. Yeah, don't worry. They're going to get like worse later. Maybe I should have picked like, I don't know. In the chat, would it have been better if I just picked the worst questions imaginable? Or are these like a little bit cheerful? The reason why I bring this up is because if you don't know trig values and they want to test you on that in the no calculator, I wouldn't like overly stress about trig, but you know, make sure you know your simple stuff too. So cosine of pi over 3 is 1/2. Okay, so 24 is B. If you forget this, so a little trig lesson. Okay, if this is equilateral, 2, let's say this is 60 degrees, 60, I drop this down. In altitude, then this is 30. It bisects the opposite side. Pythagorean theorem tells you this is square root 3. So cosine pi over 3 is cosine 60, which would be 1/2. Yeah. Oh, all right. The reason why we start with these is I try to do this in order, like limits, easy limits, tricky limits, easy derivatives, like trickier ones. Although like these derivatives here, yeah, I guess this is trickier than the one we just did. Yeah, it's thought for next year how to make these a little better. But here we go, an annoying chain rule. So one like this, if we rewrite this as cosine of 3x to the second power, now we're doing the chain rule. So we're doing the derivative of the outside power rule. Oh, here we go. See, 26, it's going to get bad. And then, see, we power rule the outside to the first power. Now the derivative of cosine 3x is negative sine 3x. Okay, but that's the derivative of the outside of cosine 3x. We still have to multiply by the derivative of 3x is 3. Whoops, 3. Okay, and now here I have a positive times a negative is negative. 2 times 3 is 6. I have sine 3x, cosine 3x. And that's choice A. Cool. Shouldn't it be left 3? Oh, I think we're referring to this one. No, this is one of those opposite things that like where life isn't fair. I know math is filled with those. Let me just see something. Is this? I want to. Yeah, you know what? Let me just freeze. Yeah, hang on. I'm gonna open the calculator for a second. So, I like that would be a no calculator question, but if I look back at that one, if I go to y equals, and I type in 2 plus math, right, absolute value, x minus 3. I'll zoom 6. See how it puts us here. Okay. If I want to go to the left 3, I would change this to plus 3. See, and we go into quadrant 2 of the vertex. All right, so good question. All right. Oh, 26. Maybe, is this not as easy? So here we go. This looks pretty bad. Maybe. I don't know. This one is like definitely a little bit worse. So the derivative of arc sine is the same thing as sine inverse. Is this. Okay, so here, if I want an equation for a tangent line, I need a slope and I need a point. So I need to know the derivative here. So dy dx, I'm going to do the derivative of the outside arc sine is 1 over radical 1 minus the inside x over 2 squared. But then I multiply by the derivative of x over 2 is 1/2. If you want to do this like kind of like a u substitution style, you could say u equals x over 2, du is equal to, what's it called? Oh, I could say du dx is equal to 1/2. So some people might like to use Leibniz notation. They'll say y equals arc sine of u, and then dy du equals this. Okay, so this is like using Leibniz. This is the shortcut going this way. If you use Leibniz, then you're using the Leibniz chain rule, dy dx equals dy du times du dx. So maybe, you prefer to do this, and then you got 1/2 times 1 over radical 1 minus u squared, and u is x over 2. It's going to give you the same thing. Okay. For the multiple choice, though, where time is like precious, I'm more likely going to do the shortcut like this. But now we need to know at the origin is the point 0, 0. So here, I'm going to plug in x equals 0. And we're going to have 1 over radical 1 minus 0 squared, when I do 0 divided by 2, times 1/2. And this is going to give us 1 times 1/2, which is 1/2. Now this is my slope. So I could use the point slope form equation. I could say y minus 0 equals 1/2 times x minus 0, which is y equals 1/2 x. And then we're like, oh no, the answer's not there. So here, let me just erase this. Okay, so we got this. And I'll move this up. Actually, let me group this and I'll shrink it. Oh no, did I press group? All right, so here we go. Okay, so y equals 1/2 x, and you're like, the answer's not there. So if you multiply the whole equation by 2, now you have 2y equals x. So I can subtract 2y and say x minus 2y equals 0. Why they wrote it in standard form, I don't know. But 26 should be A. All right. Yeah, 2x speed. I tend to explain it like a little bit slower because I don't want to like blast through all of this. So yeah, 2x speed is like totally like good, like, for people who are like already have like a pretty solid understanding and just want to blast through. So this is like chain rule and heavy algebra. So they told us the derivative of f equals this. The derivative of g equals f of x squared. And now what's the derivative of f of x to the third? But we're taking two derivatives. Okay, like this basically means like the derivative of the derivative of f of x to the third. So here, I'm going to derive this first and just say, I'll write it over here, that we have the derivative of, and now I'm using chain rule. I'm doing f prime of x to the third. So I derive the outside and keep the inside the same. But then I'm multiplying by 3x squared. Okay, so this is like the chain rule in function notation. The derivative of f of g of x is f prime g times g prime. Okay, so this is like a pretty good formula to have. So then now I got to derive this. So I will use the product rule. I'll say u is f prime of x cubed, and v is 3x squared. Okay, so this is 3x squared. And then u prime is chain rule f double x to the third times 3x squared. And then v prime would be 6 times x. All right, I'm going to get rid of this because that's just a formula that you need to know. And let me see, I got to group this strategically. Well, you know what? I'm just going to resize this. Okay, so group, resize. I'll put it here for now. So now when I derive this stuff here that I have written in pink, you see how we're doing u prime v. So I'm doing f double x to the third times, I have 3x squared times 3x squared. See, I'm doing this times this. It's going to give us 9x to the 4. And now plus, I'm multiplying these two. I have 6x times f prime of x cubed. All right, so 27 brings us to this step. Now, just looking here, the only one that has 9x to the 4th, I don't see any other 9x. Like, I'm tempted to say this one, but then I'm like, oh no, this says f double. So then here is where we have to use the other information. So I'm going to erase this now because I already did this. And this is where like it gets a little fun. All right, I'm tempted to say this, but I want to be 100% sure. So here, the derivative of f is g. So they're telling us that f prime is equal to g. Well, if f prime is equal to g, then f double is equal to g prime. Okay, so that's all from, like, that's what this is telling us. This one is telling us that g prime of x, the derivative of g is g prime, is f of x squared. So watch what happens now. So this one, see, f prime is equal to g. I'm going to use that over here. So this is going to be, in the next line, I'm going to say equals plus 6x. And then instead of f prime, I could just say g of x to the third. So you see how like this piece is already matching? Like this part is good. It matches this. But now this part, f double equals g prime. So I could say that this is g prime of x to the third times 9x to the fourth. But then see what they said over here? G prime is f of x squared. So when I replace g prime with f, I have to square the inside. I have to take x to the third and square it. So this is like some really fun algebra, but I don't know. It's kind of like a little bit cruel. So f of x to the third squared times 9x to the 4. And I'll just write it underneath. Plus, we have 6x and then g of x to the third. Okay, and then x to the third squared becomes x to the 6. So it checks out. Wow. Why does that question exist? It's nuts. But I mean, those are the kinds of questions that are like nice to look at. Sometimes they just want to see how good your algebra is. So yeah. Yeah, calculus is like 70 to 80% algebra. So just be good at algebra and you'll be fine. Like here, you could use implicit differentiation or you could have algebra skills. So if you are like the implicit champ, then you'll just derive this as is. You'll say, okay, so this is going to give us cosine x equals, now be careful, don't just say e to the y. The derivative of e to the y is e to the y dy dx. Okay, just remember we're using the chain rule. The derivative with respect to x of e to the y is the same thing as the derivative with respect to y of e to the y, but then times dy dx. We have to use the chain rule. And you can see like dy over dy cancels, bringing you back. So that's the math that we're doing. And then here we solve for dy dx by dividing by e to the y. But in the beginning, they told us that e to the y is equal to sine x. See that? E to the y is sine x. So I could just make a substitution. And then cosine over sine is cotangent. So this is this. But a cooler way to do this, so I'll get rid of this now. If you want to see it again, just rewind. Part of me wants to forget that question ever happened. Yeah, that was a rough question. I'm glad, though. It was fun. All right, so here, the cooler way. So this is like, let me change colors. So if you do it this way, you get style points. Ready? Sadly, there's no extra credit for style. So if I natural log both sides, now this cancels, and I have y equals natural log of sine x. So then I'm going to write y prime is 1 over sine x. That's the derivative of the outside. It's 1 over the inside. And then times the derivative of sine is cosine. And it gives us cotangent. Okay? So, yeah. Yeah, at Alexi, yeah, part 1 answering, I'm guessing, yeah, you're answering questions in the chat, which I appreciate. But, yeah, BC is going to be more tomorrow because if you look at the posters for AP Calculus, units 1 through 5, there's like no BC topics. It's not until unit 6 that you see your first BC topic, which is like improper integrals, partial fraction decomposition, yeah, and yeah, like those techniques are, and yeah, like that's like the beginning of the BC stuff. All right, so this is like crazy chain rule. You ready? So here, if I have dy du, which I'm getting from if y is tan u, times du dv times dv dx, if these all cancel, like just imagine like this canceling this, you see how it gives us dy dx. Like this is all equal to dy dx. Okay, so here, I'm just going to go piece by piece. I'm going to find each of those. So dy du is secant squared u. Then I'll say du dv. You know what? Let me write it maybe over here. So I'll change colors so it doesn't collide with this. So du dv, the derivative of v is 1. Think of this as v to the negative 1. So like minus this. I'm going to have plus v to the negative 2, or plus 1 over v squared. And then for dv dx, the last piece, so dv dx is going to be 1 over x. So now I could just find all of this. I'm going to piece it all together. Maybe I'll just move this down. These are my pieces. So dy du, I'm sorry, dy dx is dy du, that's secant squared u. And then times, we have du dv is 1 plus 1 over v squared. And then we've got dv dx is 1 over x. But notice these letters don't match. Oh, integration by parts. Thank you. Yeah, I didn't get a ton of sleep yesterday, so that's the kind of stuff. I know the math, don't worry, but I'm just like a little fuzzy on like doing math and then remembering like names of things right now. But all right. So now here at x equals e. So this is where it's like kind of like a chain reaction. So here, if x is equal to e, we could just kind of go down the line here. Then v would be natural log e, which would equal 1. And if v is equal to 1, then u is equal to 1 minus 1 over 1. See, that is 1 minus 1 over 1 if v equals 1, which is going to be 0. All right, and if u is equal to 0, well, we don't have to worry about like what y is equal to because we're plugging in u, v, and x. Okay, so now I plug all of this in. So ready? We have dy dx at x equals e equals secant squared u is 0. So I'm going to have secant squared of 0 times 1 plus 1 divided by 1 squared. And then times x is equal to e. So times 1 over e. And now for the remainder here, secant squared, just know secant of 0 is 1 over cosine 0. And cosine of 0 is 1, so this is 1 over 1, which is 1. So now this I could just say is 1. Oh, I'm sorry. I'm over here. So let me just section this off. So this equals secant squared 0 is 1 times 1 plus 1 is 2 times 1 over e. And then this just makes 2 over e. I like that one too. Okay. For a 5 at William L., it depends on the test. Yeah, it really depends on how like hard the test is or how easy it is. Because if like they overcook the test, then it's going to be a lower like threshold to get the 5. If they undercook it, then it's going to be harder to get the 5. So yeah, that's how it's going to work. All right. Question 30, the meaning of a derivative. The derivative tells you the rate of change. So the cost, like what I'm imagining here, the cost in dollars, like it's a function of the weight. Okay, so I would say C of W. Okay, so the cost, so the y-axis is dollars, and the x-axis weight is in pounds. I'm just going to say like C of W. Of the following, which is the best interpretation of C, that's a prime, of 500 equals 80? All right, well, if you think about like rates of change, that's how I like to think of it. C of W is starting with dollars. And then, so let me just, C of W is dollars. And then C prime of W is going to be like dollars per pound. And if I were to derive again, it'd be dollars per pound or dollars per pound squared. Okay, so I'm really just looking for dollars per pound. The cost to shred 500 pounds of documents is $80. Like, no, this would be if it was C of 500 equals 80. Then yes, but this is C prime, not C. The average cost, no. Average cost would be C of like, I just think of like F of B minus F of A over B minus A, which is not the case here. Increasing the weight of the documents by 500 pounds will increase the cost to shred. No, that's like still like that average rate of change idea. So that's not really it. So then whatever's left has to be it. But the cost to shred documents is increasing at a rate of $80 per pound when the weight, yeah, so this is like instantaneous rate of change at a specific moment in time. Okay, so instantaneous, rate of change because it's at a point. The other one, when it's like a slope of a secant line, is average rate of change. This is at a moment in time. So choice D. All right. So implicit differentiation. When you derive a y term, tack on dy dx. Okay, remember, like something like derivative of x squared is 2x, but if I derive y squared with respect to x, don't just say 2y, you got to say 2y dy dx. Okay, so that's the big idea. So here, reason being is I use the chain rule. I'm really doing the derivative with respect to y of y squared, but I can't just swap x and y and hope no one notices. I have to multiply by dy dx. You could see like dy over dy would cancel, bringing you back. So like that's like the concept, okay? But the AP test is coming up, so I guess you could just worry more about how to do it. And here I'm going to derive this equation. Okay, so we have this. All right, so we're going to derive this, and remember the concept. Now, the piece that I could think back like almost 10 years, I've been teaching a little bit of time now. This is my 11th school year teaching. This is where most people mess up. Okay, so this is like, be careful here. So be careful of this, specifically because of the negative. People forget to distribute the negative. So the derivative of x to the third is just 3x squared. This part is very nice. But here, if you have to, just use the product rule and define u and v. I call this in my class like training wheels. And if you have to put the training wheels back on, like don't be ashamed. It's better to be safe than sorry. Okay, so here, the derivative of minus 2x is minus 2. The derivative of y is 1 dy dx. So now I'm doing u prime times v. So I have minus 2 times y. And then I have minus 2x times dy dx. The most common mistake here is that people don't distribute the negative and they get like minus plus. All right, so now that was this piece. The derivative of 3y squared is 6y dy dx. Now, the second most common mistake is that people are so proud of themselves they derive the left side correct that they forget to derive the right side. And now from here, the rest is algebra. Okay, so just be good at algebra. Yeah. So let's see here. This, I would factor the dy dx out, but you could also like just move these terms over. Some people prefer to just move the non-dy dx's to the right and they leave the dy dx's to the left. So let's say, we go that route. We go plus 2y on both sides. And we go minus 3x squared. We got this and this. All right, so we're here. And now in the next line, we're going to have 2y minus 3x squared equals, and just to save time, I'm going to factor out dy dx. So we have dy dx times negative 2x plus 6y. And now I'm going to divide. And now a moment of truth. Let's see. So the top should have a 3x squared and a 2y. So it looks like 31. I think I get my answer key. Yeah, it should be B. So we're looking at this and we're like, all right, so you see there's a 3x squared and a 2y, but then you're like, wait a minute, they don't match. The reason why they don't match is because the people who made the test, or made this question, I should say, moved the dy dx terms to the right side. They didn't keep it on the left. So how do you fix this? Because you might be thinking like, oh no, like it didn't work. Like, what do I do if this happens to me? Is when we get, let me just shrink this down. Let me see. Think of a spot to. Yeah, I'm gonna do this. I'll group this all together. Okay, yeah, just so I have space to write. So when we get here, the dy dx equals, and like let's say this version of the answer we don't like. Like, oh wait, how do I know that B and this are the same? All you have to do to fix it, because you can't read their mind. Like they moved it to the right. Most people keep it on the left, but whatever. Is you multiply the top and bottom by -1, which with fractions is allowed. You're allowed to multiply the top and bottom by the same thing. Except 0. Don't make it 0 over 0. That would just be silly. So now if I do -1 times -3x squared, that's 3x squared. -1 times +2y is -2y. over negative 1 times 2x is 2x. And then negative 1 times 6y is minus 6y. And now it's like a direct match, okay? So that's how you fix it. So, all right. Here, this one might, yeah, this one's like a little out of place. Yeah, I'm sorry. When I put this together, it like zigzags a little. It's not like linear difficulty. A chain rule is like really important to be good at. All right, so here, let me just group these and shrink this down. Okay. So 32, we are going to do the, think of this as sine of 3 minus x all to the second. So first I'd find f prime of x, which is 2 times sine 3 minus x to the first power. And now the derivative, see I have like an outer middle inside. The middle function is sine. When I derive sine, I get cosine and I keep the inside the same. But now the derivative of 3 minus x is negative 1. Okay, so add 0. So now we just plug in 0. I'm going to get 2 sine of 3, cosine of 3, but then all of that times negative 1. So this is going to be negative 2 sine 3 cosine 3. So just when we thought we were done with chain rule, right? There's more. All right, here we go. Related rates. So related rates. What is the... All right, let's see here. The area in square units... I'm sorry, when the area in square units of an expanding circle is increasing twice as fast as its radius in linear units, the radius is. So here, read that part carefully. The area is expanding twice as fast as its radius in linear units. So that means dA dt is 2 times dr dt. All right, and I would just reread it one more time to make sure I did this right. Like if you put a 2 on the wrong side, it's going to throw everything off. So the area of an expanding circle, so the area is increasing twice as fast as its radius. So the area is increasing twice as fast as the radius, so this is good. Remember, dA dt is the rate the area changes, and dr dt is the rate of change of the radius. But they're talking about area of a circle, and the area of a circle is pi r squared. So now for related rates, you want to derive with respect to time. So I derive this equation with respect to time. I get dA dt equals 2 pi r dr dt. And now what I'm going to do is I'm going to replace the dA dt here with 2 dr dt. All right, so this is like where we like now have to make a substitution. Okay, so we make the substitution here, and it's going to get us like the, what's it called? The part that we need. All right, that's basically what's like all that's going on here. Now, you might be looking at that and say, wait a minute, if I plug in here, like how does it simplify? But there's a few different ways you could handle it. You could plug in for this. So let's say we replace dA dt. That's 2 dr dt equals 2 pi r dr dt. So now I'm going to divide. I want to solve for r. I want to know what the radius is. I'm solving for r. So I'm going to divide by 2 pi dr dt. Divide by 2 pi and then dr dt. So see you later. See you later. And now here, see you later. See you later. We're just left with 1 over pi. So r is 1 over pi. Okay, so that's, yeah, that part is it. Oh, Ed Samuel, I appreciate the thanks. I'm just happy to help, and thank you all for being a part of this. For real, it does mean a lot. When I started the channel way back when, I can't believe like where it's at today. It's like just really cool, and it's students like you that come in and like help me spread the word and are like really lighting up the chat. And like that's one thing I'm really grateful. Like this group, I can just tell already. Like you're all, it's like a nice group in the chat, and I'm just like happy we're all here together, like getting through this practice. Um, it means a lot, like just having you here. And it's the same thing in the classroom. Like when you have your whole class there, and like everyone's, I'll use your lingo, like locked in. Um, it's like it's fun to be a part of it, and the time just goes. Like I can't believe I'm already on here an hour and 40 minutes. It just feels like the time is like going by like super fast. It's not like dragging for me at all. I I'm happy I chose this profession, and YouTube is just a way for me to like scale it up even more. So thank you. You know, I appreciate you all for being here. So more related rates. We have the radius r of a sphere is increasing at a uniform rate. Okay, so drdt is 0.3 inches per second. And at the instant when the surface area becomes 100 pi. So surface area is S equals this. So if we set 100 pi equal to 4 pi r squared, see, we divide by 4 pi. And this tells us, I'll write it up here, that r squared equals 25. So square root both sides or do the math in your head, and r is equal to 5. R equals 5. So what is the rate of increase? All right, so here, like this was like in my class, I call this a side quest. So we had to solve for what is the radius when the surface area is 100 pi. At William L, thank you. I do appreciate the I try to press the thumbs up. I thought I could click on your like. I like the post, but thank you so much for the donation. It means a lot. So here, this part is like just like kind of a side quest. All right, the part that I did here, and then eventually we'll get back to the main quest. All right. So here, the actual goal, the question is asking us, what is the rate of increase in the volume? So here, volume they gave us. So I would take the derivative with respect to time of the volume formula. So we have this. So this is dv dt equals, and then we have 4/3 pi times the derivative of r to the third is 3r squared dr dt. Okay, 3 over 3 cancels. And notice the derivative of volume has a component of surface area. Like you see, like the 4 pi r squared is just like kind of built in here. So equals 4 pi r squared dr dt. If you wanted to, it's a little fancier. You could replace 4 pi r squared with s and just plug in 100 pi directly. You know, that might be cooler, depending on your style. But, all right. So now dv over dt, so now for the actual answer at r equals 5 is, yeah, see, we just go right back to 100 pi. So it's like we're just running in circles. Oh, no pun intended. And then dr dt is 0.3, which I'm just going to write 3/10. All right, this, let's say it's no calculator. 5 times 5 is 25 times 4 pi, so it's 100 pi times 3 over 10. So see you later to this. 3 times 10 makes 30 pi. And that's choice E. Cool. All right, so moving on. Let's see here. All right, so derivative of an exponential function. So logarithmic differentiation, which is like a extension of the implicit. Oh, at the Salmon Ramirez, low key, take a brain break. Yeah, usually I sprinkle in brain breaks because I'm kind of just going like full speed ahead. But yeah, I was just, let's see, what time are we? Oh, 9:44. We're at a reasonable time. It's not crazy late. It's no, but in my class I do that. We have double periods, but I put a brain break halfway because I know if we just go straight, it's like just too much. And plus, it gives me a chance to like say hello to everybody and connect and see how everybody's doing and all that stuff. So yeah, it's yeah, good to just check in with people too. Yeah, sorry, a lot of talking. Um, my classes are like an hour and a half each, so I'm already like over my double period. All right, so this, if you memorize the formula for derivatives of exponentials, like you just know this, like the derivative of a to the x is a to the x ln a, then you'll finish this, like, I guess, somewhat quickly. You'll just say, oh, 10 to the x squared minus 1, natural log 10, but then the derivative of the exponent is 2x. So then, is this one? Yeah, just choice. That looks like choice D, and it is. If you forget this formula, let's say, oh no, I forgot this. So back up, you would do natural log y equals natural log of 10 to the x squared minus, x squared minus 1. And then you got natural log y equals x squared minus 1 ln 10. And then we derive with respect to x. This is more conceptual. And you get 1 over y, I'll write y prime, equals the derivative of x squared minus 1 is 2x times ln 10. This is constant. So when you derive a constant times a function, you just leave the constant alone and derive the function part. And now I solve for y prime by multiplying by y, and I get 2x ln 10, put these in parentheses, times y. And y originally is 10 to the x squared minus 1. So I get the same answer either way. Okay. Multivariable calculus. That's impressive. I'm trying to add that to my school, but they didn't go for it because this was the first year they did AP pre-calc. So they didn't want to add too many math classes, but I'm like secretly hoping I get to teach it one day. I'm very rusty. I haven't done Calc 3 since like 2009 when I think you were all like, yeah, like toddlers. So it's been a while. All right. Oh, here we go. Unit 5-ish. Yeah, this is like Unit 5 stuff. First derivative test. So f is continuous. F has a relative max at negative 1, 4 and a relative minimum at 3, negative 2. Which of the following statements must be true? Think and draw. Okay, so draw and then think. Okay, I should have wrote that next to it. Yeah, that looks better. So draw and think. So here, what I would do is just draw out. We have negative 1, 4. Let's say is here. We have a max. And at 3, negative 2, we have a minimum. So maybe like something like this. But it's which one must be true. So, oh, okay. I see it's tempting to say this. There must be a point of inflection. A point of inflection is where the second derivative changes signs. Or you could just think of it as a place where the graph switches from concave down to up or concave down to concave up. So you see the change in concavity the way I drew it. This could be true, but it's not a must be true. Because just know you can have a local extreme value that looks something like this. It could go like this. And it could go like this. So let's say this is negative 1, 4. And that this is 3. And then negative 2. So you could have something piecewise linear. So let's say this is piecewise linear. Then the graph doesn't have any concavity to it. So this, yes, but which one must be? Like it's a must be true, not could be true. And here it's not true. So that's out. F prime of negative 1 is 0. This could be. Here it's true. See how, let me change colors. We have a 0 slope if it's smooth and differentiable. Or if it's differentiable, it's smooth. Then we have a 0 slope. But over here, we have a sharp turn, and it's a critical point where the derivative does not exist. Remember, a critical point, almost everybody just says, oh, where f prime is 0. But the sneaky one is where, like, let's say I have like f prime of c does not exist. So f prime of c does not exist. and C is in the domain of F. Okay, so this is like, this I like to call the sneaky critical point. So people get like very tempted to just say, oh yeah, if I have a max or a min, F prime is 0. But no, this is the sneaky one. All right. The graph has a horizontal asymptote. That's not a must be true. The graph of F has a horizontal tangent line at 3. Nope, it could be a sharp turn, and then it doesn't have a tangent line. So it has to be this one just by process of elimination. And yes, it has to intersect both of the x and y axis, because they told us in the beginning the function is continuous for all x. So if I'm going from a height of 4 to a height of -1, see that? I'm going from 4 to -1. I'm using the intermediate value theorem here. The concept is IVT. To go from 4 to -1, I have to pass through 0. So we have to hit the x-axis. That is unavoidable. And we have to hit the y-axis also, because they said f is continuous for all x, which means f is continuous, like f of 0 has to be defined. So that means it's going to hit the y-axis. So it's going to hit both. We're going from 4 to -1, so we're hitting the x-axis, and the function's defined at 0. So choice E. Good question. No one is reviewing for AP Physics C. Isn't that I know there's like that team of AP teachers that do like the ultimate review packet. I mean, not to what's it called? Not to like I mean, I'll advertise for them. Ultimate review packet. I know there's like that whole team. But flipping physics, I thought that guy does AP Physics, but I don't know. Maybe one day I'll learn it just to live stream it. I don't know. I don't know how popular of a test it is either. I don't think like there's a lot of people who take it. All right. Oh, linear approximation. So linear approximation, the concept, f of 5 is equal to 3. Let's say this. And the slope here is 4. So it's like a pretty steep tangent line. Let's say, yeah, it's like rising and running pretty quickly here. So I'm just imagining, I don't know, a curve. The curve could look like anything, but like maybe it just looks like this for now. All right. And what is the best estimate for f of 4.8? So what we want to do is write the equation of the tangent line. So we need a point, and this is our point, and we need a slope. So here, think of like the equation y minus y1 equals m times x minus x1. Back in the algebra days when life was easy. So y minus 3 equals the slope is coming from the derivative. And then times x minus 5. So this tells us y equals 4 times x minus 5. And then plus 3. Make this neater. Plus 3. And then from here, if we want to approximate f of 4.8, what's happening is like, let's say like, oh, I want to know what's going on here at 4.8. And like at 4.8, I don't know what's going on with the function, but I know what's going on with the line. So that's what we're doing is we're plugging it into here. This is our tangent line. So it's going to be a decent approximation, I'll say, because 4.8 is close to 5. Tangent lines are only accurate when you're close to the point of tangency. So here we'd have 4 times 4.8 minus 5, and then plus 3. So this is going to make negative 0.2. And 4 times negative 0.2 is negative 0.8. Plus 3 is going to make 2.2. So A. All right, 37 is A. Cool. Yeah, it's basically Euler's method, but with just one tangent line. Tomorrow I'm going to do Euler's method when we do units 6 through 10. But Euler's method is like basically just like make a second tangent line. So it's, yeah, that's why like BC, at least like before 9 and 10, I don't think BC is like really that much harder, but then units 9 and 10 like tend to take people's souls. So, yeah. These are all AB questions for now because it's units 1 through 5. BC doesn't start till unit 6. So here, MVT guarantees the existence of a special point on this graph between here and here. What are the coordinates? So, all right, MVT, you just have to know the conclusion. This is not like the free response where you have to write a sentence. But here, it's f prime of C equals f of B minus f of A over B minus A. Now, the concept, because that's just an equation, but what is it like? What does it actually mean? And if you want to be good at theorems, I would draw the theorems out to really get a like strong understanding. So I'm going to sketch square root x here. And we're going from 0, 0 to 4, 2. So here's 0, 0. And then 4, 2, we'll say is like 1, 2, 3, 4, and then up 2. So what we're finding here is like this is the average rate of change. And this side is the instantaneous. So MVT says that if your function is continuous on a closed interval and differentiable on the open interval, then at some point C between A and B, the instantaneous rate of change is going to match the average rate of change. So if I clone this, let's say I just duplicate this. If my slopes are equal, the lines are going to be parallel. Like the existence of the C value, I'm just imagining like, oh, it's like somewhere over here. Okay, like that's the concept. Is like the point where the tangent line has the same slope as the secant line. So moving on. So now, like this is the concept, but for the question, just formula. You don't have to know this for the question, but I like to explain a little more too, so it's not just, just plugging in. Oh, and this is y, but I could call it f of x. Doesn't matter. The derivative of, think of this as x to the half, is 1/2 x to the negative half, which is 1 over 2 radical x. And now here, I want to know when is f prime of c, so when is 1 over 2 radical c equal to the average rate of change. Now we find the average rate of change. And the average rate of change from x equals 0 to x equals 4 is going to be f of 4 minus f of 0 over 4 minus 0. Okay, so this is going to be square root of 4 minus square root of 0. And this is going to give us 2 over 4, which is a half. Not right? Okay, so 1/2. I'm just doing square root of 4 is 2, divided by 4 is a half. So that's our average rate of change. So now we just do a little algebra. We want to know when is this equal to this. And one thing I see right away is like, oh, with this equation here, when I have this, kind of like anything goes, like just do the algebra. But the 2 over 2, like the 2's here just cancel. I could do times 2 on both sides, and then like the 2's just wipe out. And now if I have basically like one, not equals, arrow. If I have 1 over 2 radical c equals 1 over 1, I'm sorry, this canceled out. So so 2 over 2 cancels, and 2 over 2 cancels. So I have over here, now I got to erase. I have 1 over radical c equals 1 over 1. This tells us c is going to have to equal 1 here. Okay, so I didn't draw this amazing, but it should happen at 1, 1. Okay, because if I plug in like x equals 1, I get y equals square root 1, which is also 1. Better algebra to do maybe, like if that was like, wait, what did you just do? Is I could also just cross multiply here. So if you'd rather just cross multiply, just say 1 over 2 radical c equals a half, and you just do this. And it tells you 2 radical c equals 2, or square root of c equals 1, still c is equal to 1. Okay, so if I would have drew this better, it should have happened over here, but whatever. All right. Cool, that's 39. All right, we're getting there. We have 11 more questions here. Okay, or actually 12 because it's inclusive. All right. So, oh, this one. The 4 emojis of curve sketching. You ready? So we could have f prime, f double prime. If f prime is positive, your function is going up. If f double prime is positive, your function is smiling. So this, positive f prime, positive f double, your function is increasing and it's smiling. Positive f prime negative is increasing but frowning. Looks like this. Try that again. So I call these like the 4 emojis because they look like emojis. If f prime is negative and f double is positive, we're decreasing and we're smiling. Okay, so decreasing with a smile. So those are the 4 shapes to know. And then minus minus is decreasing with a frown. Okay, so it's like probably the grumpiest looking one of the bunch. Okay, double negative here. So now they're saying y prime is positive. See, y prime is positive, y double is negative. So plus minus is this. So I'm just looking for something that looks like this, which choice B right away just jumps out. Okay, this one looks like plus plus. It looks like y prime and y double positive. This one looks like minus minus. See? And then this one is like a mix. Okay, we want it to happen for all x. So this one, it switches. Like it's concave up, then down. So here it has to be, 39 is going to be choice B. All right, cool. So if you all were to take the test tomorrow morning, like what score do you think you'd get? Let me know in the chat. I'm just curious where people think they're at right now. Like, how are we feeling? Oh, we get to use a calculator for this. So motion. So v of t is equal to this. And then ln of 0.2 t. Oh, it said, William, you want to go for the, you really want a 5 or? Yeah, I know it's in the high 4s. Okay. Yeah, Alexi, I think, you're pretty strong right now. But that's a good that's a good mindset to have, good attitude that like the Dunning-Kruger effect, which is like what is it? Confidence and competence. So the danger is like people might be like, oh, all right, starting here, and like they go like, hey, and then like, whoa, I actually don't know anything, and then like it starts to go up. Okay, this is very dangerous. Okay, so just be careful. Like here is like, the valley of despair, but this is the path to enlightenment. So yeah. Took a mock exam and got a 4. Very nice. Yeah, that's did a 2020 test, got a 5, but it was just by a few points. So yeah, William, I know we talk about like almost calling it like a super 5, that you want to like really seal it, that like if like a 70ish is a 5, you want to get like 80s 90s, and then like you're guaranteed the 5. So I know what you mean. That's good though that you're taking it so seriously. All right, so this one is like not that bad at all, and it's a calculator question too. So the concept you need to know is that you have position, you derive with respect to time, and you get velocity. You derive with respect to time, and you get acceleration. Position tells you like where you are. Okay. Velocity tells you like how fast and direction. And this is kind of like where you want to go. Okay, because I could be going like if this is a particle situation, I could be going like here, but like I'm accelerating left. So like I have to like I'm going fast and I have to slow down first and then I go backwards. Okay, so it's like where you want to be going, but you're not necessarily going that way. But if you're accelerating in the same direction you're going, then you're going where you want to go. So great. All right. So the acceleration, I just derived this. So I want to know what is v prime of 1.2. And for this one, I'm just going to use the calculator. So finally, the calculator. So let's see. So I'm just deriving this and plugging in. So math 8, derivative of 1.3. And I'm going to make sure I get my decimal there. So 1.3 t ln of 0.2 times t and then plus 0.4. And this is happening at 1.2. And this one is working out to choice C. Okay, so choice C. Just borrow this. And okay, you just chop this out. So it's like not too overpowering. All right, so choice C here. And I know it's calculator because there's no way, unless you have a computer brain, you're going to get these numbers. Oh, you took a mock exam and got absolutely well. You know what? Then it's good that you're here. That's what the point of those mock exams are, to like kind of like wake you up a little bit. Gives you like a little jolt. Okay, so you'll be all right. You manually derived and plugged in. Okay, so all right. If you want to manually derive, then just use the product rule. That works too. But math 8, because you're gonna need to plug in a calculator anyway, so you might as well just math 8 it. Another nice option in the calculator, if you don't know this one, so I'll show another calculator thing because like I got to make this review as comprehensive as possible. Is I go to y equals, and let's say I type in that same function, 1.3, and it was t ln, but we're going to use x, and it was 0.2 t plus and plus 0.4. Okay, I'm just referring to my paper so I don't have to keep flipping back and forth. All right, that was our function. So what I could do is I could press math 8 and derive, but then watch this. If you have this calculator, the TI-84 plus CE, you could press alpha trace Y1. And then just, I saved it in Y2, and I just type, same thing. Okay, or I could press second trace dy dx is number 6, and I write in 1.2. Same answer, see? It actually points us to the graph. So yeah, use those calculator tricks when it's allowed. All right, so moving on here to 41. We're nearing the ends. So let f be a twice differentiable function. Values of f prime, that says, the derivative of f at select values of x are given in the table. Which of the following statements must be true? Okay, so this is once again a table of f prime. Now, the trap here, f is increasing. People might be thinking like, oh, f prime is positive. They're like, positive, positive, positive. But it's a table at selected values of x. Okay, so there's a possibility here, like maybe f prime of 1 is equal to like -3. Like maybe this thing's going up and then it spikes back down, like immediately after 0. So that's possible. So A is out. The graph of f is concave down for -1 less than x. All right, so concave down, if you think about that, concave down is when f double prime is less than 0. But it's also when f prime is decreasing. Okay, or the slope of f is decreasing. So that's what I imagine with concave down is like, here's our concave down curve. And notice like the slopes are positive, but then they flatten out and then they become increasingly negative. So that's when the slope of f is decreasing. So here, like f prime is decreasing. Like, yes, that's true, but for the same exact reasoning here, I could say like, all right, well, maybe f prime of 1 is actually equal to, instead of going like only down, it goes up for a second. It goes like to 10. Then this one is not true. Right, so like now it's like, oh no, like I'm running out of ideas. Like what's going on? Which of the following statements must be true? Notice here, there exists a value c between -1 and 5, where f prime of c is -3/2. So this, a -3/2 is -1.5. If this is a table of values for this, then this is like IVT territory. But notice we're going from 11 to 2. If we're going from 11 down to 2, and this is at like x equals, -1. I'm starting here. Like, let me actually write that over. So I'll say this is 11. I'll put -1 over here. Starting here, at 0, we're at 9. And then at 2, we're at 8, 4, 5. And this is a table of f prime. So 4 brings us to 5. This was 8. This is 5. And this is 2. That -1.5 is down here. I'm not guaranteed to pass through this. I am guaranteed, though, to pass through everything between 11 and 2. See, like there's no way for me to skip anything between 11 and 2. Like I'm definitely passing through 7. I'm definitely passing through, like if I'm focusing on these numbers, I'm passing through 7, I'm passing through 10, I'm passing through 3, numbers between 11 and 2. Guaranteed by IVT, but this is not between. So this is out. Process of elimination has to be this. But why? Well, from -1 to 5, let's just see here, -9 over, So this one here is more MVT territory. We take the average rate of change. So I'm doing f prime of 5 minus f prime of -1 over 5 minus -1 is equal to 2 minus 11 over 6. And then -9 over 6 reduces to -3 over half. I'm sorry, -3/2. So this is the average rate of change. Okay, the average rate of change of f prime at some point will be equal to the instantaneous rate of change of f prime, which is f double prime. So that's why this is good. What throws people off is like MVT says something like this. But then the moment they apply MVT to a different function, it could be very tricky. But I'm going to show you MVT for f prime, okay, is when you have f, I'm going to add in a prime with a different color. If I add a prime here, then f double prime of c will be equal to f prime of b minus f prime of a over b minus a. So that's basically what we did. We applied MVT to f prime. So this guarantees that f double will be equal to this. And they said because f is twice differentiable. So all of this is possible because f is twice differentiable. So choice D. All right. So, our emojis again. Remember our 4 emojis. So if we remember the emojis from before, let me see, how far back was that? Oh, here they are. Let me borrow these guys again. All right, we'll take them with us. So here, not that far of a height. Okay, perfect. So at which of the 5 points on the figure, on the graph in the figure, is dy, dx, and the second derivative both negative? So negative, negative, now we're looking at this one. So where is it decreasing and frowning? Like here, okay? So it's going to be at point B. Okay, so that's why I like the emojis so much. They're just very helpful. This part, the increasing frown, is plus minus. Here is minus minus. C is located at like decreasing, smiling, and this is like plus plus. This one's like kind of debatable, but it's definitely not like minus minus. Okay, so gotta be that one. Choice B. Oh wow, we have 562 people stop by. Yeah, thank you all for the support. This is like just like very cool, like to have you all on board here. All right, so let's see. We've got f is the function with derivative defined by this. How many points of inflection does the graph of f have on the interval 0, 9? Okay, so that's an f double prime sign change. Okay, that's what we're looking for. Ready for some calculator magic? So here we go. I'm going to bring up the calculator here. So let's take a look. So if I want to find f double prime, I could do a derivative, but it's a calculator question. There's no way you're graphing that by hand unless you have a computer brain. So math 8, I'm deriving 2 plus 2x minus 8. And make sure you're in radians for this, because if you're in degrees, it's going to like ruin the question. And then sine of x plus 3. Okay, so we're doing this. And I'm going to write x equals x. So the calculator will derive this for us. How nice. And now window, I'm going to go 0 to 9. Because that's the interval, 0 to 9. And I'm only looking for a sign change, so I could go from like -5 to 5. It's not a big deal. So we graph 1, 2, 3, 4. 4 sign changes. All right, I'll explain this carefully. Let's get rid of all that extra fluff we don't need. Okay, so goodbye to this. All right, so 40, this is for question 43. All right, this is our graph of f double prime. We derived f prime in the calculator. So remember, f double prime, sign change. So see how here it's changing signs once. Here it's going from positive to negative, negative to positive, positive to negative, negative to positive. Okay, so there's 4 points of inflection. So calculator magic. All right, so moving on. Let's see. It's Saturday. There's a break. Yeah, Friday I need a break. I'm gonna do, because I'm also doing tutoring at my school on Saturday in the morning. So I don't want to do like, I need a little pause. So plus, a little brain break. But this will be on there if people miss, they could watch. All right, so let's see. Oh, free response. Yeah, so at It's Your Pal, Saturday, I'm going to do 10 free response questions. Okay, I'm doing 10 FRQs. And I'm going to go far back. I'm going to pick ones that I think are still relevant, but I'm going to go far back because I think teachers are more likely to stick to like the last 10 years. So I'll go back like by the time I was in high school even. Okay, and I'm going to pick questions that I didn't go over in class. Do I ever get tired of math? I honestly don't. Here, a little brain break, and I'll talk to you all. 10:18. Yeah, I could afford to do this. So I'm gonna grab something real quick. I read this book recently, uh, Ikigai, the Japanese secret to a long and happy life. And one of the concepts, is this gonna show up? Oh, cool. Ikigai is what you love, what the world needs, what you could be paid for, and what you're good at. Is the overlap of all of those. And they say that if you find something that fits all of those and puts you in a state of flow, but in like, Gen Z language that lets you lock in, then that's the key to happiness. And like for me, like honestly, 2 hours and 20 minutes went by, but I'm feeling good. Like I'm like, all right, it's math. I taught math all day. I taught math for 3 hours and 45 minutes in the morning. And now I'm teaching it, like I'm teaching it a long time today, but it's something that I think is like I don't know, it brought a lot of value to my life when I was a math major, and I like to share that with people. I like my ultimate goal is to get students to see the value in learning math and leveling up. It's not even like you got to be the best in the world at it. It's just you're just trying to better yourself, and you're getting better at analysis and whatnot. So, like that's honestly how I see this. So bored, no. I might get tired or hungry, but I'm not. I'm definitely not bored. You all bring it to life. Like maybe if I was just, even if I was just doing math on my own, like I could find questions that I think are interesting to think about. Like I have other books too on like history of math books and whatnot. Like have like a decent library um of stuff to keep me busy. Puzzle books. So yeah. But I have other hobbies too. Like I play guitar. I do Brazilian Jiu-Jitsu. I'm a black belt in Brazilian Jiu-Jitsu, so that's fun. That's like my my exercise. So it's good to have I mean somewhat of a balance. Like you do want to commit to something to get good at it, but I like to have those other outlets to keep me like keep my mind healthy. All right. Yeah, you could get to a 4 to a 5. If you're at a 3 right now, it depends on like if you're like a just making the 3 or you're like a high 3. Like depends where you are on the scale. But if you go all out, Barb, like you might surprise yourself how much you can learn. There's still a decent amount of time. It's only Wednesday. Got Thursday, Friday, Saturday, so like 4 full days of like really going all out. Um, yeah, is like really good. Oh, brains and brawn type stuff. Yeah, that's um wait, 2018 multiple choice. Oh, I can't go over anything like international practice exam. That has like the unauthorized redistribution, whatever. Like that stuff that they only release in the classrooms, like I can't put that online. Um so yeah, I'm gonna play by the rules because like you could get in trouble like with like your AP license and whatnot. So I'm gonna that's why I carefully chose the material. Like I can't put anything from AP Classroom up, anything like that. So yeah, I'm gonna stick to these questions, but don't worry. Tomorrow's questions too are pretty good. So here, average rate of change. So f is a function such that f double prime is less than 0. So concave down. All right, concave down is telling us that f prime is decreasing. Okay, so f prime is decreasing for all x. Okay, so this is what's happening. So here, if I find the average rate of change, I'm just going to go on like a slope frenzy. I'm doing 4.38 minus 4.18 divided by 1.2 minus 1.1. And this is going to give us like, what's that, 0.20 over 0.1. And that gives us 2. So the slope here is 2. But you could also calculate that if you want. If I find the slope here, 4.56 minus 4.38 divided by 1.3. So the change is still 0.1. That's like something that's just continuously happening here. And then that's 0.18. So 1.8 is going to simplify to, and it does. Cool. All right, so here, and if I do one more, the average rate of change from on this interval, I'm doing 4.73 minus 4.56. I promise there's a point to this. Okay, over 0.1. So here, this one, 17, so 1.7, I want to say there. I'll just double check it. I don't think you need to see me type in on the main screen like how to do that. But yeah, 1.7. Just double checking because I don't want to put anything like out of place up here. So what we have is notice the average rate of change is decreasing as well. Like this is the average rate of change. This is another average rate of change on a different interval on the second subinterval. And then this is another average rate of change. Okay, so you see we have average rate of change, average rate of change, average rate of change. And they're going and they're dropping. So now we go through this one by one. F prime of 1.2 is less than 0. That's not true. Because if if f is concave down for all x, so like, f is concave down for all x, then f double is less than 0 for all x. Okay. For all is upside down capital A, I promise. This means for all. So for all. Okay. So here, that means the slope, f prime, is just continuously decreasing. It's not allowed to go back up. That's why the average rates of change are also continuously decreasing here. So now we look to the next one. F prime of 1.2 is between 0 and 1.6. No, that wouldn't be true. F prime of 1.2 would have to be between these two. F prime of 1.2 would have to be between 2 and 1.8. So looking at it right away, like D is just jumping out. F prime of 1.2 has to be between this average and this average because it's dropping. Remember, it's kind of like MVT mixed in the middle too, that if the average rate of change is 2 from, let's say, like here to here, then at some point the instantaneous has to equal 2, and it's just dropping forever. Okay, so that's why it's got to be D. Could I go over, let's see. Oh yeah, free response questions I'm doing on Saturday, and I'm doing 10 of them. The other streams are going to be at 8 o'clock also. Sunday, I'm going to plan. I have it scheduled. So if you go on my channel and you go to, let me just try to get you all a link. So yeah, if you go to my channel page, specifically the, what is it? Hang on one moment. Whoops, what am I pressing? Sorry, just, yeah, here we go. I'm logging in now. So YouTube Studio. Okay, content. Yeah, although this one, I guess I could just view my channel on all right, so live. Yeah, here it is. So for people asking the questions in the chat, hopefully this link will get you there. Okay, but these are my streams coming up. And you can see they're scheduled. So I might update Sunday. Right, like right now we're in the day 1, but for day 4, like stay tuned. I'll try to give you as advanced notice as possible. Otherwise, for now, I'm going to stick to that time. All right, so let's see here. We have the derivative f prime. At what values of x does f have a relative minimum? We want a relative minimum on 0, 3. So relative minimum is when f prime changes from negative to positive. If you forget this, let me try to draw that again. That's better. So here is a relative or local minimum. And look what happens with the slope. The slope goes from negative to positive. The slope of the tangent line changes. It goes from negative to positive. And then if I have a relative maximum, let's say here, a relative maximum, that is a slope change from positive to negative. Okay, so that would be if they wanted the relative max. So now calculator, considering that, we go to the calculator and let's see, f prime, we're going to type in negative x over 3. If you want, if that bothers you, you could write alpha y equals x. Alpha y equals enter will make a blank fraction. And you get negative x over 3, and then it like basically matches the question. Okay, although they put the minus in front, but it's the same thing. It's going to give you the same value. So here is the derivative. We're going to look for where does f prime change from negative to positive. So window, we're going from 0 to 3. And I'm going from negative 5 to 5. So now I just press graph. And remember, I'm looking for where the derivative goes minus to plus. That's the second one. This is a plus to minus. It's going from over to under. And the third one goes over under. So here, what I'm going to do is I could graph the line y equals 0 and see like what is the second 0 here. Second trace 5. I scroll to the neighborhood. I get close. I press enter 3 times. And that would be the value. So let's see. So 2.371, 5 rounds to 2.372. So 45 should be choice C. All right, we're almost done. 46. So given the function defined by f, find all values of x for which f is concave up. So we'll do this without a calculator. Concave up, we're looking for where's f double greater than 0. So power rule twice. So 15x to the 4 minus 60x to the second. And then one more time. We have 60x to the third minus 2 times 60 is 120. Then we have x. And now this makes 60x times x squared minus 2. Okay, so for this one, what is helpful here is like being able to find the roots. So we want to set the second derivative equal to 0. Okay, so f double prime, we let it equal 0. And this is going to give us a root of x equals 0. This one, quadratic piece, is going to give us roots of plus or minus square root 2. And if you need to, you could just say, oh, x squared minus 2 equals 0. And you could always just do the algebra on the side. Okay, you could say x squared equals 2. And then square root. But don't forget the plus or minus. That'll like ruin the question if you forget it. Okay. So then from here, what we're going to do is I could factor this even more because that's going to help with the when we have to make the sign chart. Okay. So we have all of our roots are x equals 0 and x equals plus or minus radical 2. So I'll give you some tips for making the sign chart so that it's like not so terrible. So we have 0, then we have radical 2, and minus radical 2. So here, if you want to use like difference of two squares, you could even like think of factoring this as like x plus radical 2 times x minus radical 2. But this is optional. Okay, this is optional. You don't have to do this. So now we plug in test values. Like let's say here, I plug in something like, I don't know, like I plug in -3. When I plug in -3, let's say I plug it in here. If you do this math in your head or you write it on the side, f double prime of -3 equals, I'm going to have, if I plug it into this factored form over here, I'm going to have 60 times -3. Like I'm doing this math usually just in my head, is negative. And then I have -3 in parentheses squared minus 2. And that's going to give us 9 minus 2, which is positive. So I have a negative times a positive is negative. Then the next thing that jumps out at me is here. These are all like odd powers. This is like x to the first. Sign changes all throughout. I know it's going to go like this is going to like go on from here. If you want to, you could plug in something like -1. Like let's say you plug in -1. You could plug it into the factored form. You could even plug it into this form. Plug it into your favorite one. You could plug it into 60, let's see, -1 to the third minus 120 times -1. And this is going to give us -60 plus 120, which is greater than 0. So that's going to give us a plus. Okay, and if we do that for the others, we're going to get minus, and we're going to get a plus. But our goal is to find where is f double positive. So it's here and here. So what are those two intervals between -√2 and 0? So basically that eliminates everything except b. And let's see, -√2 to 0, but also greater than √2. So 46 is b. All right. I don't really get 45. Do you have to derive f prime of x? No, you don't have to derive because they're like relative minimum is where f prime goes from positive to negative. And they already gave us f prime. Okay. So at Michael, if this was a different question, so alternate universe 45. If they said blah, 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 f of x equals negative x over 3 plus cosine of x squared, then you would derive first. And the calculator would do it for you. But if we did it, that would be negative 1/3. And then this would be minus sine of x squared. That's the derivative of the outside. The derivative of the inside is 2x. And then we would look for the sign change from minus to plus here. But they already started us at f prime. So that's why we could just jump right into it. All right, but good question. You got to be very careful. Think about what they gave you and what you need to find. So if they gave you f prime and you need to find where f prime changes from negative to positive, then you just use the calculator to see where that happens. All right. Oh, I'm happy to help. That's why I'm doing this. I'm glad I could clear up any confusion. And please, anyone else, if I explain something and it's like still fuzzy, like make us all better and ask a question, because I say the same thing in my classroom. When you ask a question, you're the brave one, and you're asking a question that like 5-10 other people probably had. Are the relative minimum and max always the zeros? No. Sometimes you're going to have like an absolute value function. And this is a local minimum. But notice this local minimum is where the derivative is undefined. So this is the sneaky kind. Okay, so not always. 46 I did without a calculator because it's possible. If I could do a question without a calculator, then I will. This is like kind of like borderline, just more annoying than difficult. Like making that sign chart is just kind of tedious. Another trick though is that these all have odd multiplicity. So once I find the sign of 1, I could just say the rest are going to alternate. It's going to be minus, plus, minus, plus. So that's a little more advanced, that method. Oh, this is a good question. Let's see. So 3 graphs, Roman numeral 1, 2, and 3 are shown above. One is the graph of f, one is the graph of f prime, and the other is the graph of f double. Which of the following correctly identifies each of the 3 graphs? Ooh, all right. So process of elimination. Maybe 1 is first. If 1 is first, notice that 1 starts off decreasing. So like what if 1 is f of x? Well then, the only possibility here for 2, I'm sorry, let me start that sentence over. The possibility for f prime, like if we're saying, hey, I think Roman numeral 1 is f, it's decreasing. So that means that f prime, see, like it's decreasing. So that means like f prime would have to be negative. But from here to here, you see, like from like 0 to almost like 0 to a half. From 0 to a half, this graph is positive. This graph is positive. So this is not possible. It would have to, from 0 to a half, be negative. So then that gets rid of, this possibility. I'm only marking up the diagram so that we could I can model my thinking. But I don't need to mark the diagram to answer this. I just look and think. So then, what if Roman numeral 2 is f? Well, if Roman numeral 2 is f, this one from, let's say, this looks like a 0 slope here. So this looks like slope 0. So if this is f, then here, f prime of 0 would be 0. And then this looks like 1.5. This looks like a local maximum at 1.5. So here, just looking, you see how f prime of 0 is 0. This looks like a potential graph of f prime. And then that would mean like Roman numeral 3 would be f prime. And let me see if the rest of the graph behaves the way we need it to. So we have a local max at 1.5-ish. And notice here, we have a change from plus to minus. I guess it's not perfect. It could be like a little bit over. And then let's see, it decreases between 2 and 3. So I'm sorry, it starts to decrease at 1.5 and then it starts increasing again at the end. So yeah, see, f prime is negative on this whole space, which means f is decreasing. So this is looking good. And then Roman numeral 1 by process of elimination would have to be f double. And let's see, the graph is concave up, concave down, and then concave up again. So if it's concave up, it's like f double positive, f double negative, and then f double is positive again. And positive, negative, positive. Yeah, so this is like most likely it. Like it's going to be 2 is f, and then 3 is f prime. So this one's out. But like, why can't it be the last possibility? So I'm just going to explore once more. So why not this? So why not 3? All right. So if we look at the last case here, if Roman numeral 3 were f, where's the contradiction? So why is this not possible? Well, this one here, it's going up. So it's like f prime is positive, which they both are. And then there's a local max here. So a local max means we need a sign change from positive to negative. And then we need a sign change here from negative to positive, which we have that over here. But there it is. Okay. So I see the contradiction. Yeah. So it's like almost, but then if we look at this graph, see how we're concave down here. It's frowning. So that means f double is less than 0. But if this is f double, it's not starting less than 0. So that's why this one's out. Definitely see. Yeah, those questions are I'm sorry, definitely choice, what did I say? Choice let me just reread this one more time. 2 is f. I just want to make sure 2 is f. Positive. Let's just see here. I want to see, make sure I didn't miss. Yeah, I want to like reopen quiz B for a second. I want to reopen those just to make sure but definitely Roman numeral 2 is f. Yeah, sorry. Question 47, I start to like fizzle out a little bit. There's a lot of talking. So let me just see. 2 is f. And if 2 is f, let's see. We have a local, looks like almost like a local minimum at this location here. So 2, 3, and 1. Yeah, that one's looking is looking good. I'll double check though. The slope, let me see. We have the slope is 0 at 0. Yeah, the slope is 0 at 0 is like kind of the giveaway here. So I think I said I was leaning towards C, but I'll double check this one if I need to, and I'll if I have to address it. So I'll just say like day 2, we will like revisit if we need, if necessary. Okay, if necessary, if needed. All right, but yeah, that one, if I just like wrap it up one more time, like f, yeah, because I just want to like make sure. So f has a local minimum here. So we need a minus plus sign change in this neighborhood, which we have, but we don't have here. So yeah, that one is like looking the best. 2, 3, 1. All right, cool. All right. So 48, the graph is concave downward for all values of x such that. So here, y prime, I'll just rename this -5 x minus 2 to the negative first. And we're going to have 5 x minus 2 to the negative second. And now this one, I could call, I'm going to leave it b because we have to do concavity. So we need the second derivative. So y double now, I could say is -10 x minus 2 to the negative third power. And I don't have to use chain rule here because the derivative of the inside is 1. So it's like, yeah, not super necessary to include that times 1. So negative 2 times 5. All right, so this is our second derivative. And now we want to know concave downward is where y double is less than 0. So we have a vertical asymptote at x equals 2. That's where the denominator is 0, and x minus 2 doesn't cancel out. So it's not a removable discontinuity. It's an infinite. I'm sorry about this. This is like freaking out on me. X equals 2. Okay. So here, what I need to check is, oh, this is like giving out on me now. Hang on. There we go. Wait. All right, that'll do. Oh, I think because I'm switching pages, it's like set with me. Maybe if I draw it over here. Yeah, that's way better. So we have a vertical asymptote at 2. So when I make the sign chart for y double, the sneaky one to consider is the vertical asymptote. Okay, so if I plugged in 3, I'd have like y double at 3. Something to the right is going to give us negative 10 over 1 to the third, which is less than 0. So I have a minus here. And if I plugged in something like 0, let's say I do y double at 0, I have negative 10 over negative 2 to the third. And that's going to give me a negative over negative is positive. Okay, so we're concave down from 2 to infinity, which is going to match up with choice E. Okay, so this is choice E. Cool. Optimization. Yikes. Yeah. So let's see. This one. Oh, at Michael for graph 2, why does f prime? I hope that made sense. So thank you for answering in the chat. But here, yeah, this one, like I said, I'm going to revisit 47. So you could like start on your papers or something if you printed it out. But yeah, the slope of the tangent line here appears to be 0. So that means the derivative has to be 0 in the neighborhood of 0, which this one, it's like definitely not. This one says it's like really increasing here, which it's not increasing there. Okay. But it is concave up in this neighborhood. It goes concave up, concave down, concave up. So yeah, that's why I really yeah, 2, 1, 3 is not possible for the second derivative if I just use concavity, because this would be like concave up, concave down, and then concave up again. And this is, oh wait, this is plus minus plus also. Oh, but you know what? I guess this part, it's, if this is our second derivative, yeah, I'm like just, it's going to bother me if I don't get closer. Here we go. So this is concave up, concave down, concave up, if that's our second derivative. But this one would be like concave down, concave up, concave down, concave up. But this one doesn't go like concave down, concave up. So yeah, I'm happy with choice C. I don't think I need to. I'll look at it again, but I'm like good now. Yeah, I was just like having a moment. I was like, wait, what? I'm like, but that's what you got to like during a test. Look, if I took the AP test with all of you, I would hope to get a 108, right? But if I don't get a lot of sleep or something like that, I might miss a question. I might miss like something in the multiple choice or in the free, like it's going to happen. So they catch you on your A game when you're feeling sharp and you're like super focused, then awesome. But otherwise, just got to get like to a level where you're feeling super strong. Okay, the point on this curve nearest 4, 1 is, so optimization. All right, we're almost done. But of course, we got to do something crazy before we end. So 4, 1 is somewhere here. And I'm just tempted to say y equals a half x squared, just so we get the concept down. So a half x squared will have 0, 0 on it. So 0, 0 is definitely here. And then if I plugged in half of, let me see, if I plug in 2, half of 4 is 2. So like this point here. All right, and it's a parabola, so it's going to go, let's say, something like this. Let me draw that a little better. Just because I want people to get the concept. One more time. That's a little better. Okay. So here's our parabola, and we want to know like which point on the curve is closest. Honestly, if you draw this neat enough, it's like probably this one. It's like sure 2, 2. Please don't do that on the test though. Like just try to be an artist. I mean, yeah, if it works, that's like a loophole. But I'm going to show you how to do it the math heavy way. So whatever the point is, let's say we didn't know it was this. We're going to call it xy. And this is the 0.41. And I'm going to call the distance between them z. I'm going to use z because if I use d, it just like, I don't know, using d when I have to do the derivative is like, just kind of like, it's going to say like dd something, like dd over dx, and it just looks funny. So I'm going to use z. But I'm going to say here that if you remember the distance formula, you could use that, or you could use a Pythagorean concept. But basically, I could say x minus 4 squared. Let me write z squared first. I'm going to say z squared equals x minus 4 squared plus y minus 1 squared. Okay, so here's this. And what I'm going to do is I could say like square root and solve for z, but I don't want to do that because this is annoying to derive. I'm like, ugh, I don't want to derive that at all. So what I'm going to do instead is I'm going to turn this into a function of x. So see this piece? The y I'm going to replace with 1/2 x squared. You'll see why I'm not solving for z in a moment. Because when we derive, we're going to set dz over dx equal to 0 anyway. So we have this plus 1/2 x squared minus 1 squared. So now what I'm going to do is like this is the distance squared. So I want to know when we're closest to, like nearest to means the absolute minimum distance. So I would want the square of the distance to be as small as possible. So our goal is to minimize this, like, so minimize. So this is where we derive. We're going to derive with respect to, let me change colors. We'll derive with respect to x. All right, so we're going to get 2z, so implicit time, dz dx equals 2 times x minus 4. I don't have to implicit, like chain rule this piece because I'm deriving with respect to x. And then same thing here. I do power rule on the outside. And now the derivative of the inside is just x. Okay? Because it's 2 times 1/2 is 1, and then this. I can't derive. I don't have. I like that. I appreciate jokes like that. Thank you for. What unit is optimization? I think it's 5. Yeah, I think it's 5. So now, if I want to find the minimum value, we're gonna set dz dx equal to 0 because whatever this function looks like, z, whatever this thing looks like, we just care about like where the absolute minimum is. It's like, all right, I have some function, like absolute minimum is where the derivative is going to be 0 there. Right? Because this is like polynomial based. So it's not going to be like sharp turns. It's going to be smooth. All right, so ready? So we set this equal to 0. It's going to wipe out the left side. Now the right side is going to be 2x minus 8. I'm just distributing. And now this, I'm distributing 2x. Okay, so just say here like I'm doing 2x times a half x squared minus 1. And that's going to give me 2x times a half x squared is x to the third. And then I get minus 2x. So now watch, 2x minus 2x is gone. And I get x to the third minus 8 equals 0. Now plus 8 and cube root tells you x equals 2. And if x is equal to 2, we solve 2y equals 2 squared. Tells us y equals 2. So x equals 2, y equals 2 gives us this. Okay? That's a hard question. Yeah, it's kind of like annoying. But this little trick of not square rooting, otherwise you're going to have like a nightmare chain rule. All right, final question. Somehow we made it. I don't know how, but we did. All right. So here, relative max, f prime goes positive to negative. So here, we're going to use the product rule. I'm going to say u equals x minus 2 and v equals x minus 3 squared. So u prime is 1 and v prime is 2 times x minus 3. So algebra skills, here we go. Well, at the end, we're going to need algebra. U prime v is x minus 3 squared. And then plus, we have 2 x minus 3 times x minus 2. So now factoring skills. You ready? We're going to take out at x minus 3. If I divide this by x minus 3, I have x minus 3 left, which I'll just write. Plus, if I take out this x minus 3, I have 2 x minus 2 left. I'll write it over here. So f prime of x equals x minus 3 times, and now this is x minus 3 plus 2x minus 4 after we distribute. So go here and here. So now you got x minus 3, and this is going to make 3x minus 7 on the inside. Okay. So now we have roots. F prime of x equals 0 means x equals 3, and x equals 7 over 3. So this is like 2 and change. So 3 over 7 is less than 3. 3 over 7, 7 over 3, I'm sorry. Yeah, I'm really fried. We're almost done though. All right, shortcut. Ready for a cool shortcut. So f prime has 2 roots, here and here. And I notice if I were to do x times 3x, that this is gonna, I'll write it up here, gonna be like x times 3x is 3x squared plus blah, blah, blah. But since our a value is 3, which is greater than 0, this is a smiling parabola. Okay, so a greater than 0, let me change colors here. A greater than 0 means it's a smiling parabola. So it goes plus, minus, plus, okay, f prime. So when I make my sign chart and it's a quadratic f prime, if f prime is leading with a positive coefficient for x squared, then it's a smiling parabola. If it was negative 3x squared, it would go like this as it hits the roots, and it would be minus, plus, minus. So where's our relative maximum, where the sign changes from plus to minus? At 7 over 3. So choice D. All right. Somehow we made it through 50 questions, and we'll do this tomorrow too. But thank you all so much for being a part of this and asking questions, answering each other's questions in the chat. This was like really like just an awesome group. And we had 750 people watch, and it's only Wednesday. So I like really thank you for being a part of this. It was wasn't that the only solution? You know what? I guess it was. So, but you know what? It's good to practice because a better test would have put x equals 3 in there. But yeah, somehow, yeah, we made it. Okay. Well, would you do if it had said absolute? Well, absolute can only happen if you have a closed interval or if there's only one critical point. So that's like one extra little detail. So absolute extrema. So for an absolute one, they would have to do two cases. Like they could give you something like this and you're on a closed interval and you're like, oh, here's my absolute min and max. You could also have something like this. This is like a situation where like you think like this is the absolute, but it's only a local. And then like this is the absolute. This is the highest point. That's why when you have like a closed interval from A to B, that's why you have to check the endpoints. Okay, like people think, oh, it's probably not one of the endpoints, but sometimes it's both of the endpoints is the max and the min. All right, otherwise the sneaky absolute extrema is when you only have one critical point. So like let's say I have something like this. Let me try that again. All right, I guess that's marginal, a little better. If I just have one critical point, and notice it's like a sign change from plus to minus, this is a not only a local max, it's also the absolute max. Okay, but that would be once again if this is the like only critical point. So this only works when you have one. Okay, but otherwise, yeah, if they want you to find an absolute max or min, they got to give you like a closed interval. Good luck on your physics test tomorrow. I'm glad it was helpful at Maria. Yeah. So, yeah, thank you all for supporting. I am going to sign out, but I will be back tomorrow at 8. What unit are all these concepts? Unit 5. Yeah, unit 5 is really big. 1 through 5, I think 5 is like very important. So you should, study that for sure. If I had to rank them in order of importance for like Calc AB, so Calc AB, like, unit 6, and then like 5, then maybe 8. I don't know, they're all important, but these are like the high. Like, look at the percents in the. You know what? Tomorrow, I'll give it a better look and all that. So yeah. All right, but take care. Yeah, and good night, and I'll see you all tomorrow. Oh well, if you decide to come by, I hope you do. But otherwise, happy studying and good night.